Now that we have a better understanding of how enums work and we've solved the issue of comparison with some mystery strings, let's move on to the next big issue with our program. So our next big issue is that our source of data is hard-coded. What do I mean by that? Well, if you go back over to our index.ts file, at the very top, we've got that logic to open up the CSV file and parse all the data inside of it. So I want you to imagine for a second that we decided to get our football data from some outside API rather than the CSV file. If that were the case, we would have to come into our index.ts file and comment or otherwise delete all that CSV related stuff, and then replace it with some logic to make a network request to get some data, and then operate on that instead. So when I say that our source of data is hard-coded, I mean to say that if we wanted to ever change our source of information to our program, we would have to make a very significant change to the structure of our program. We would delete like over half of our source code, or otherwise comment it out. So in this video, we're going to figure out some good way to somehow extract this logic and make it, at least somewhat reusable. The logic we have right now to open up the CSV file is actually common logic that we could use on any type of CSV file. So we can take any type of CSV file and essentially feed it through these lines of code right here, and we'll get some representation of the data inside of that CSV file. And so I think that beyond the fact that we don't want to delete some code that we spent a lot of time writing, well, this actually is some pretty good code right here that we could easily reuse on a future project. So how are we going to extract this and, number one, keep us from having to delete it if we decide to have an alternate source of information, and number two, make it available on future projects as well? Well, here's my idea. I think that we should create a separate class called a CSV file reader. The CSV file reader class is named such because it's going to literally open up a CSV file and read it. So the word reader right here indicates that this object is going to attempt to read or capture some information. I think that this class could have two fields. One field would be maybe the file name or the name of the CSV file that we want to open. And then the second field would maybe be like some data variable that would eventually be all the parsed information out of the CSV file. So data would start off empty when we first create the class, and then once we actually open up the file and capture some information from it, we'll then assign all that information to data. And then finally, to actually open up that file and parse all the information inside, we should create maybe like a read method. So anytime we call read, we will actually open up the file, grab all the information out of it, parse it all, and then assign it over to data. So if we create some class like this, then we could very easily reuse it in the future. And in addition, if we create a class like this inside of a separate file, then we can easily decide to change the source of information inside of our program without deleting all that very valuable CSV reading code that we already put together. So let's give this a shot. Let's try creating a separate class inside of a separate file that's going to have these fields and that read method as well. All right, so to get started, inside my src directory, I will make a new file called csvfilereader.ts. Then inside of here, I'm going to create a class and immediately export it. So I'll export class CSV file reader. Now, like we just said, I think this thing is going to have two fields. One's going to be our file name. The other is going to be the actual reference to the data that we captured out of the CSV file. So I'm going to first initialize data. I'll say data is going to be a two-dimensional array of strings. And I'm going to initialize its value right here in line and say that it's going to start off as an empty array. So eventually, we will throw some actual data inside of here. Now for the file name, we could initialize that right here, but instead, we probably want to pass in the file name as an option to our class. So chances are, if we ever use our CSV file reader class on a future project, we will probably not always be opening up something called football.csv. Instead, we should make the file name an option so we can customize it and use our class to open up different CSV files. So with that in mind, rather than declaring this property right here, I'm going to instead define the constructor, and we're going to receive file name as an argument to our constructor. Now notice I'm using the public modifier right here. All that's doing is automatically defining a property on our class called file name. And so whatever we pass in as the first argument when we create a CSV file reader will be assigned to a file name property on our object instance. I don't think we actually need any logic inside the constructor, so I'm going to shorten up those curly braces to just be on the same line like so. All right, so that looks good. So now the last thing we will do is put together a read method. And this is going to be responsible for actually opening up that file, parsing all the information, and so on. So I'm going to define a new method called read. I don't think it's going to return anything at all, so I'll give it a return type of void. And then inside of here, we want to open up that file and so on, so I think it's going to be this exact same logic that we already have inside of index.ts. So inside of here, I'm going to copy and paste all that stuff from fs.readFileSync all the way down to the bottom of our map statement. So I'm going to cut all that. I'm going to go back over to my read method, and then I'll say this.data is going to be the result of all that logic. And then finally, we need to make sure that we import the fs module at the top of this file. So I will import fs from fs at the top. And okay, I think that's it. Everything inside of here looks good. So let's now try to use out this brand new class right away. Back inside of index.ts, I don't need to import fs anymore. Instead, I'm going to import CSV file reader from CSV file reader. Then rather than declaring a variable called matches right here, I'm going to declare a variable called about reader. And this is going to be a new CSV file reader. Don't forget, we have to pass in the name of the CSV file we want to open as an argument to the constructor. So I'll say football.csv. And by the way, that reminds me, I think I made a little typo inside the class. Back inside of our class definition, right here, when we call it read file sync, we're still hard-coded to open up football.csv. So rather than using that hard-coded string, let's instead use that property that we're now passing in. So I will replace football.csv with this.filename. That's better. Okay, so now back over inside of index.ts, after creating our reader, we'll then call reader.read to actually open up that file, read all the information, and then assign it to the data property. And so now finally, down here where we try to iterate over our matches, we can instead iterate over reader.data, like so. All right, so I'll save this file. I'm looking at my folder explorer over here. It looks like I don't have any errors, and so I'm ready for a quick test. I'm going to flip back over to my terminal and just make sure that I can still see that Man United has won 18 games. Yep, still works. All right, so this is definitely an improvement. So now if we ever decided to use an alternate source of information inside of our program, like say some API, we would not have to delete all that very valuable logic around opening up that file and then parsing all that information. Instead, we would only have to delete or otherwise comment out the line of code that created an instance of the file reader and the actual read method. That's it. Deleting these two lines right here is way more palatable, definitely way more preferable, than deleting all of this rather customized logic right here. So we would just have to delete these two lines and replace it with some other code to make some API request to fetch our data. In addition, we've now also got a class that we could very easily use on future projects as well to open up and read data out of CSV files. And I really mean that. Like, you could use this class right here on your own projects in the future to open up CSV files. So I think there's a huge benefit here in extracting that CSV reading logic into a separate class. All right, so I'd say this is definitely an improvement. So let's take a quick pause right here and move on to our next issue in the next video. We've now extracted all the CSV file reader logic, but we still have a lot of work to do. So let's go back to our list of outstanding items. Okay, here we go. So the next thing we're going to work on is the fact that our data array is all strings, even though there are definitely some different types of values inside there. So to help you understand what I mean by this, I'm going to flip back over to my index.ts file. And then right after we read the contents of that CSV file, I'm going to add in a console log for reader.data, like so. All right, so I'm going to save this, flip back over to my terminal, and now we can see all the information coming out of that CSV file. So notice how we have some numbers inside of here that are still wrapped inside of strings. So I think that we need to somehow parse those numbers out and put them into the overall data structure that we're getting back out of that CSV file reader as actual numbers, as opposed to the strings that they currently are. In addition, you'll notice we also have some date strings inside of here as well. And they have the format day, month, year. Having the date inside of here as a string is not super helpful. So I think we should also try to parse that string and turn it into an actual date object as well. Now, something I want to clarify here and make sure it's really clear is that we're kind of talking about doing two operations. So first off, I want to take these different values that are currently being treated as strings and actually are strings, and I want to parse them into some appropriate value. So in other words, I think we need to take this string right here that represents date and turn it into an actual date object. And then in the case of the number of goals scored, those are currently strings. So we need to parse those strings and get numbers out of them. So at the same time, not only are we doing this kind of parsing logic, but we also need to kind of update the types that these different values are going to be stored as inside of our data array. So the first element should be an instance of a date object. That should be its type. And then for the number of goals scored, those should be number types. And for the result of the match, we should make sure that it's really clear that this is one of the different values inside of our match result enum. So we're not only talking about parsing these values and getting a different value, we're also talking about updating their type definition inside of the CSV file reader as well. Okay, so let's take a quick pause right here. When we come back in the next video, we're going to start working on a function that's going to take that date string, parse it, and return an actual instance of a date object. So quick pause, and I'll see you in just a minute. In this video, we're going to work on a new function called parseDate. The goal of this function is going to be to take that string with the day, month, and then year, and then return an actual date object with it. Before we start writing any code, I want to give you a quick review on how we create a date object in JavaScript in general. So I've got my JavaScript terminal up here. I can call new date. When I do so, we can pass in some arguments to customize what day, month, and year this date object is going to point to. So the first argument inside this constructor can be the year that we want to set the date object to. So for example, I can pass in 2020, and that should create a new date object that's going to point at the year 2020. As a second argument, we can put in the month that we want this date object to point to. For the month, we have to use it 0 indexed. So in other words, January is reflected as 0, February is 1, and so on. So I could put in, say, 0 right here, and that will point to January 2020. And then the third argument is going to be the day. So if I want to do like January 1st, 2020, I would put in 2020, 0, and then 1. Or I could do like 15, and that will look at January 15th. So in effect, all we have to do here to create this date object is split apart this string right here, extract the month, day, and year. We're going to subtract the month by 1, and then we're going to feed all those different values into the date constructor. And that's pretty much it. Now to create this parseDate function, we're going to make a new separate file to store this code. This code that's going to convert that date doesn't really have anything to do with anything else inside of our current application, so I'm going to put it inside of a new file that I'm just going to call utils.ts. Utils being short for utilities. So then inside of here, I'm going to create and export a new function called dateString to date. And then I'm going to annotate this thing. The first argument is going to be something I'll call dateString, and it's going to be of type string. And then this overall function is going to return an object of type date. All right, so then inside of here, we're first going to take that date string and split it apart based on those forward slashes. So to do so, we'll write out something like about date parts is date string dot split on forward slash like so. So let's imagine for a second that the input to our function is something like, how about, I don't know, let's use one of the actual dates rather than making one up. So how about right here, we got 28/10/2018. So we've got 28/10/2018. So that means that the output from this line right here will be an array of strings with 28, 10, and 2018. These strings are not super useful to us because when we use that date constructor, we have to pass in actual numbers, not strings. So we now have to iterate through the array we get back, take each of those strings, and turn them into the respective numbers that they represent. So to do that, I'm going to just chain on a simple map statement right here. So this map statement is going to be called with something I'll just call value as just a arbitrary argument name here, and that's going to be a string. And then our goal is to return a number. I'm going to zoom out for just a second. Actually, how about better than zooming out, let's just new line this statement so we can get everything a little bit more legible, like so. All right, so now inside the map statement, we can return parse int with value like so. So parseInt is a function built into JavaScript and therefore TypeScript as well. It takes in a string and returns a number out of it. So now dateParts is going to be an array of numbers. The first element will be the day, then the month, then the year. So we can now pass each of those into a date constructor and return it. So I'll then return a new date. I'm going to first put in dateParts at 2 because we want our year first. Then we'll put in the month, which will be dateParts at 1 minus 1. Remember, the minus 1 is on here because our month inside the date constructor is 0 indexed. So January is supposed to be 0. And then finally, dateParts at 0. That's our day. All right, and that's pretty much it. Okay, so let's save this file right here. When we come back in the next video, we're going to be able to make use of this dateString to date function to convert that date string into an actual date, and we'll also handle conversion of a couple of other elements inside of each row as well. So quick pause, and I'll see you in just a minute. In the last video, we put together our dateString to date function, so now we can go through our CSV file reader, and after we read some information out of the CSV file, we can now go through each individual row and convert each value inside of each of those rows into some appropriate type. To get started, at the very top of this file, I'm going to import that helper we just created. So that's dateString to date from the utils file. And now inside of our read method, I'm going to chain on another .map statement. So we could definitely add in some logic to the .map that already exists to take each element inside of each row and convert them, but I think that it might be just a little bit more clear to just use a separate map statement, because then we would know very well that this map statement is first going to split a single string row into an array of strings, and then the next map statement will do the actual conversion process for each of those values. So I'm going to remove the semicolon right there and chain on another .map. I'm going to pass this thing a function. So our incoming value is going to be something that we'll call row, and that's going to be the array of strings. So just to make sure it's really clear, row right here, that represents one of these single rows. So an array of strings, and we want to go through that array of strings and convert each of those values into some other type if it is appropriate. And then from each of these, we're going to return, well, something. We'll get around to that in just a second. So for right now, I'm going to cheat just a little bit, and I'm going to put on any right there. Remember, in general, we don't ever want to use the any type, but I just want to get something working for right now, and we're going to come back to that and really decide what we are returning from this function in just a moment. Okay, so now inside of here, we're going to take that row of strings, we're going to go through each value inside of it and do some processing. So I'm going to eventually return a new array that's going to represent all the items inside there. So our first element is going to be the converted date string. So we want to take in that first element, run it through that function we just put together, and spit out the date on the other side. So I'm going to take date string to date and put in row at 0. And that's pretty much it. So now we're going to repeat that same process for all the other values inside the row. And then if we need to convert it, well, we will convert it on the fly. So the next two elements, we're not going to do any conversion on. Those are going to stay as strings. So the next element will be row at 1, then row at 2. Then 3 and 4 are going to be the number of goals scored. Right now they are strings. We need to turn them into numbers. To do that, we'll just use the parseInt function again. So we'll do a parseInt with row at 3, a parseInt with row at 4, and that's looking pretty good. Now the next one is going to be a little bit more challenging. We currently have a string inside of our row, and we want to make sure it's really clear that this string is going to be one of the possible values of our match result enum. So to convert a string into one of the values from our match result enum, we first need to get access to the enum type definition inside this file. Now that's going to be just a little bit of a process, so I'm going to save this file right here for right now. We're going to take a quick pause and then come back in the next video. So quick break, and I'll see you in just a minute. In the last video, we started going through our row of strings, and we're converting each value inside there into some other appropriate type. We left off on the match result value right here, so we currently have a string, which is good, but we need to tell Typescript that this string is going to be one of the possible values from our match result enum. In order to do that, we need to get access to the match result enum, or that type, inside of our CSV file reader. Currently, that enum is defined inside of our index.ts file. So we could export it from this file and then import it inside of CSV file reader, but usually by convention, we do not export anything out of our index.ts file. So to fix this, I think we should move the enum definition into a new separate file. We can then import this enum into any other file inside of our project. So let's do that refactor right now. Inside of src, I'm going to make a new file called matchresult.ts. I'll then go back over to index.ts. I'm going to cut the enum out of here, and then I'll paste it into matchresult. And finally, I'll make sure that I export it from here as well. So now we can import this enum into both index.ts and CSV file reader as well. Over inside of index.ts, I will import matchresult from matchresult. And then I'll do the same thing inside of CSV file reader as well. So at the very top, I will import matchresult from matchresult. So now finally, we can go back down to where we are writing all this row conversion logic. And we're going to take row at 5, which you will recall is the match result, so like this string right here. So what we are trying to do right now is tell Typescript that this string is going to be one of the possible values inside of the match result enum. To do so, we're going to find row at 5 right here and then say as match result. So this is what is known as a type assertion. A type assertion is where you and I, as the developers, are trying to override Typescript's default behavior, or kind of tell Typescript that, hey, we know what is going on here. So at present, Typescript only knows that row at 5 is a string. We need to override that behavior. We need to tell Typescript, hey, believe us, trust us, we're the developers, we know what's going on here. We want you, Typescript, to consider row at 5 as one of the possible values out of that enum. So now Typescript knows that that index right there is going to be H, A, or D. We're going to see a lot of type assertions later on inside this course, so for right now, we'll just kind of leave that as is. As a quick aside, I do want to mention that you can use type assertions with any kind of type. It's not limited just to being used with enums. But like I said, we'll see some more kind of usage of type assertions later on as well. Okay, so that looks good. So now the very last value we have to work with is the referee, which we're just going to leave as a string. All right, so the very last value inside of here will be row at 6, like so. And that's pretty much it. So we are taking in the array of strings, and then we are doing some conversion process, sticking them all into an array, and then returning it. So now the only big issue we have left inside here is that on this mapping function, we annotated its type as any, which is definitely not appropriate. So let's take a quick pause right here. We're going to come back in the next video and discuss how we're going to update this type annotation right here to some more appropriate type. So I'll see you in just a minute. We've converted all the values inside of our row array into the appropriate type of values, but now we are kind of stuck with this any definition right here. So we need to replace any with some type annotation that's going to describe this array right here. Now the only issue is that if we treat this thing as an array, we would have to add in an annotation that looked a little something like this. We would have to write out something like, this is going to be date, or string, or number, or match result, and then we could put on square brackets like so, to indicate that this is going to be an array that has a date, or a string, or a number, or a match result inside of it. Now this is not super ideal. You might recall that we spoke about this annotation type right here a little bit earlier on inside the course. If we ever wanted to access an element inside of this array now, we would have to do some type of type guard, which we discussed earlier as well, that would allow us to treat this first element as a date, or these two elements as strings, or these two as numbers. So we did talk about another data structure available to us inside of TypeScript that can address this issue very well. You might remember that we spoke about tuples much earlier. So remember, a tuple looks very similar to an array, but it's meant to organize elements inside of it in a very specific order. So the example that we went through with tuples, we said that we might have an object that looks like this that represents a drink. And a drink object had color that was a string, carbonated that was a boolean, and sugar that was a number. Another way that we could represent this object right here was with a tuple. So we would take brown and stick it in as the first element inside the tuple. Then carbonated was the second element, and sugar was the third element. When we were making use of a tuple, we're saying that the first element is always going to be a string representing the color. The second would always be a boolean representing carbonation, and then the third was always a number representing sugar content. If we ever scrambled this order, then our tuple would not make sense anymore. So we always had to leave the tuple in this exact order. So it kind of seems like we are in a very similar case with the row of data that we are now working with. We now are working with some row where each element inside of here is at a very specific position. The date is always first, then we always have the home team, then the away team, and so on. So I think that rather than treating this thing as a plain array that might have a variety of different types, we should instead create a new tuple definition. And this tuple will describe this data structure right here, where we first have a date, then string, string, number, number, and so on. So let's try going down that route. Let's try using a tuple to describe this row. Now you might recall the first thing we have to do to make use of a tuple is add in the tuple as a new type. So at the top of our file, we need to add in a new type definition or a type alias that describes the structure of the tuple we're going to be working with. So I'm going to go back over. At the top of the file, I'm going to add in type match data equals, and then the tuple structure. So remember, this defines a new type called match data, and we're going to say that a match data tuple is going to have this very specific ordering of types inside of it. So the first element will be a date, then a string, then a string, a number, one of the possible values out of match result, which we would express by just writing out match result, and then finally the string for the referee. So string, like so. All right, so we've now defined a new tuple inside of our app, and we're calling it match data. So now we can go back down to our mapping statement, and we're going to update this definition or this type annotation right here. So we're going to say that we're going to call this mapping function. We're going to take in an array of strings, and then we're going to return something right here that has the exact same structure as the match data tuple. Okay, so now TypeScript is going to treat this thing we are returning as though it were the match data tuple. It knows that this row or this array or this tuple, however you want to refer to it, it knows that the first element is going to be a date, then a string, string, number, and so on. Okay, so this looks pretty good. However, we still have a little error up here. So if you take a look at this error, it says that we are now trying to, well, it's kind of hard to read this error, but essentially what it's saying is that we are returning an array of tuples right now. So we have an array, and inside of it are a bunch of different tuples that conform to the match data type. And we're trying to assign that to a property that is expecting a 2D array of strings. So now the last thing we have to do is update our data property right here and change its type annotation, because we are no longer going to be working with data that is a 2D array of strings. Instead, we've got an array of tuples. So we can update our type annotation right there by saying match data, and then square brackets like so. Notice that we only have one set of square brackets right here. The reason for that is that when we say match data, we are kind of implicitly saying that match data is an array. So this is saying we have an array of arrays, and those inner arrays have a date, string, string, number, and so on. Okay, so this looks pretty good. If we now flip back over to index.ts, we can take a look at, say, reader. Actually, let's write out a console log right here. We could do something like reader.data and then put down our index notation. We could do something like 0. And when we write that out and hover over it, Typescript should be telling us, okay, it's not quite telling me here. Let's try writing out this syntax just a little bit differently. Let's try doing like const date of first match. How about that? A little bit more detailed than needed, but let's try it out. So we can then do a reader.data at 0 at 0. Oh, that's why it didn't show up. I was not putting in the correct number of indices. So we're now getting the very first match inside there, and we're pulling out the first element, which we know is going to be a date. So if we now hover over date of first match, we will see type inference kick in. Typescript knows that reader.data at the first row, at the first index, is going to be a date. And so it correctly annotates date of first match as being of type date. All right, so this looks pretty good. So now whenever we start to work with our data property and the elements inside of it, Typescript has types for all those different elements, and it understands what different types of values we are working with. So now we can try to access that data array, reach into it, and maybe do some like numerical calculation using all the different goals that were scored. Or we can access that date object and call some different methods on it to try to pull out like some very precise date-related information or something like that. All right, so this is definitely a good improvement. So let's take a quick pause right here. We're going to come back in the next video and move on to our next big issue. At the end of the last video, I said that we were going to move on to our next big issue inside of our code base, but before we do, there's one quick thing I want to point out here. I want you to recall why we created the CSV file reader class. There were two big reasons we created this thing. The first one, we had said that we wanted to have a reusable source of information into our program. So at some future point in time, we might decide to get information about these different football matches from some outside API. If we had placed all of our CSV file reading logic right here, we would have had to delete that logic, which would have definitely not been that great. We would have deleted it and then replaced it with the logic to get information from that outside API. So as a solution, we extracted all that information or all that CSV parsing logic into our CSV file reader. The other big reason we created this class was so that we would have a class that could be used on future projects as well to open up CSV files and read information from them. So we wanted to be able to use this class on different types of CSV files as well. So I now have a big question for you. Do you think, given the refactors we just did around match data and this mapping function down here, do you think this class is still reusable? Well, I would definitely say no, without a doubt. No, this thing is not reusable. And the reason for that is that we now have a ton of references to match data and this conversion function right here as well. So this class is now only going to work when we have a CSV file of exactly this structure, namely a date, a string, a number, and then a character that is either an H, an A, or a D, and then a string on the very end. If our CSV file structure ever changes from this, we would have to open up this class and start making some changes. So I would say that our class is no longer reusable. We cannot make use of this on future projects. So in this video and the next couple, I want to start to refactor this thing and make it reusable again. I still want to have the idea of match data. Like, that's very valuable. I still want to have the match data tuple, and I still want to have this conversion logic, but I want to have it somewhere else. That's all I really want to do. Now, to do this refactor and make this class reusable again, we're going to take a look at two different ways of approaching this. Two very, very different ways. So this is going to give you the ability to compare and contrast different ways that we can reuse code inside of Typescript. And it's going to be a lot of fun. Now, before we get started, I want to do one quick thing here. I want to make a quick backup of our CSV file reader. We could do this using Git, but honestly, it would be a lot easier if we just created a new file and did a little bit of copy paste. So inside of my src directory, I'm going to make a new file called csv file reader.back, which stands for backup. And then I'm going to copy paste all my TypeScript out of the current file into this .back file and save it and close it. We are going to eventually use that code later on as a starting point for the second refactor or the second version of this stuff that we're going to do. Okay, so now that we understand the goal, let's take a quick pause right here. When we come back in the next video, we're going to start to refactor this class into the first reusable version. So I'll see you in just a minute. In this video, we're going to kick off our first refactor of CSV file reader. Remember, we are going to do two separate refactors here so that you can compare and contrast different styles of code reuse in TypeScript. Before we talk about the first refactor we're going to do, I want to take a look at our read method. Inside of our read method, notice how the first half of the method has a bunch of logic that will work with any type of CSV file. So it doesn't matter what type of CSV file, what the different columns are, how many columns there are, how many rows there are, or anything like that, that logic right there will always work correctly. It's only the second half of the read method that has some logic that is customized for our football.csv file. So it's really just this anonymous function right here that has that custom logic. Before we start talking about the big refactor we're going to do, I want to extract this function right here into a helper method on the class. The reason we're doing this is just to help you understand the refactor we're going to do a little bit better. So again, this anonymous function right here, I just want to extract into a helper method. So inside of my class definition, I'm going to make a helper method called map_row. So the idea here is that we're going to take in one row, we're going to kind of convert the information inside of it, and then return it. Again, exactly what this anonymous function is currently doing. So map_row is going to take in a single row that is going to be an array of strings, and it's going to return a match data tuple. So then we can go back up to the anonymous function. I'm going to cut and paste the return statement right here into the helper function. And now rather than passing in an anonymous function to map, I'm going to pass in a reference to map_row instead. Notice how I did not put any parentheses on map_row. We are instead just giving the map function. Oh, if I can get one set, there we go. We are just passing a reference to map_row into map. So we are not trying to invoke map_row. So this has an immediate impact here. Now our read method is 100% reusable, more or less. It doesn't have any references inside of here, like very distinctly, to any specific CSV file. And we've now isolated all the custom logic into map_row instead. Okay, so now that we understand that refactor, let's talk about the big refactor to CSV file reader so we can restore some amount of code reuse. All right, so here's the idea. We're going to turn CSV file reader into an abstract class. Remember what abstract classes are in TypeScript. They are classes that we're never going to use to create an instance of an object. So we're never going to create an instance of CSV file reader anymore. Inside of an abstract class, we can have some methods with real implementations, and then we can have some methods that we're going to promise to implement at some future point in time. These abstract methods that we're going to declare are going to have to be implemented by some child class. So the overall idea here, to really sum this up, we're going to have CSV file reader that has still the read method that has some logic that is going to be appropriate for parsing any type of CSV file. Then whenever we want to parse or extract information from some very specific CSV file, we're going to subclass or extend CSV file reader. So this subclass right here, which we are going to call match reader, is going to have some information about how to convert a very specific row of data. And so this match reader would be customized specifically for football.csv. So in other words, match reader knows exactly how football.csv is structured, but CSV file reader does not. It has no idea. It only knows how to generally parse CSV files. So this is the first big refactor we're going to do, and this would be one way to get some amount of code reuse, because now we can reuse CSV file reader as much as we want. Let's imagine that maybe we want to parse some CSV file that has information about movies. We might create a new class called like movie reader. This would extend CSV file reader, and all we would have to do is implement a map_row function that like returns maybe something of type, I don't know, movie data or something like that. So now we would be able to reuse all the logic inside of read, and all we have to do is customize the conversion of a per row basis or on a per row basis. So I think that this would definitely be a pretty good refactor. So now that we understand what's going on here, let's take a quick pause right now, and we'll start this first refactor in the next video. All right, now that we understand the refactor, let's get to it. We're going to first create that class match reader and make sure that it extends the abstract class CSV file reader. So back inside of my code editor, I'm going to create a new file inside of my src directory called matchreader.ts. Then inside of here, I'm going to import the CSV file reader. From the CSV file reader file, we'll then define and export class match reader, and that's going to be extending our CSV file reader. So inside of here, we're going to eventually have to define the map row function. Let's do that right now. So I'm going to define map row. This thing is going to take a single row that is an array of strings, and it's going to return something of type match data. Because remember, that's the entire goal of this thing. This is where we are wrapping up the reference to match data. So this is going to return match data. And then inside of here, we need to return something of type match data. So hey, rather than rewriting all that stuff, let's just go back over to CSV file reader. We'll find the existing map row over here, and I'm just going to cut and paste that entire return statement. So I'll cut it, pull it back over, and paste. We immediately get a couple of errors inside of here. So let's take care of, say, date string to date. I'll import that at the top from our utils file. Next up, we have a reference to match result. Remember, that is our enum, and we define that inside of our matchresult.ts file. So let's import that as well. Cool. Now we still have an error here around match data. We're going to take care of that error in just a moment, but first, let's do a little refactor on CSV file reader first. So back inside of CSV file reader, we can go up to the top. We don't need the date string to date function anymore, so I'm going to delete that import. Next up, we'll mark our class as being abstract. And then inside of this class, we need to mark, well, we don't have to per se, but we want to mark our map row function as being abstract. Remember, we put the definition for that at the very bottom. So to mark a method as abstract, which indicates that it's going to be implemented by our child class, we just put the abstract keyword in front of it, and then we remove the curly braces for the function itself. Now, personally, I like to put abstract methods right underneath the constructor so that they're really easy to see. So I'm going to cut that definition and put it right underneath the constructor. Okay, so this looks pretty good, but there's one really big issue that we've kind of been skirting around, and you might be actually kind of wondering why we didn't discuss this in the last two videos. We've said several times now that the entire goal is to make CSV file reader reusable, right? That's the idea. And to really make that occur, we need to make sure that this file, the entire file, has no reference whatsoever to anything called match data. Because match data is customized to work only for the current CSV file we are dealing with. Match data is saying that every row is going to be a date, string, number, and so on. So match data is talking specifically about football.csv. So we need to somehow extract that type definition out of this file and not have any reference to it inside of our class. But that's going to make life just a little bit challenging. Why is that? Well, it's because our data property right here, we're saying that this is going to be an array of match data tuples. Likewise, map row right here, we are saying that this is going to return a match data tuple. So on the one hand, we're saying that we want to remove these references, but the big question is, what do we replace it with? Like, map row has to return something. If it's not going to be match data, literally, what are we going to put right there? We could really cheat and say this is going to be of type any, but that's probably not a good idea, because remember, we want to avoid any as a type as much as possible. So let's take a quick pause right here. When we come back to the next video, we're going to really outline what the issue is here and why we don't want to have match data, and we're going to discuss how we're going to fix this up. So quick pause, and I'll see you in just a minute. In the last video, we spoke about how our CSV file reader still has a reference to match data. We don't want to have any references to match data inside this file, because match data is 100% based upon football.csv. Football.csv is only going to exist inside this project, so if we want this class to be reusable, well, there can't be any reference to that CSV file, which match data essentially is. So we need to remove or ideally replace match data with some other type inside this file. One option would be to change it to any, but that's not really ideal because we want to avoid the any type as much as possible. So how are we going to fix this? Well, we're going to use a new feature inside of Typescript that we've not yet discussed before called generics. Let's take a look at a quick diagram and get a better idea of how generics work and how they're going to fix our issue. Okay, so when we make use of generics, we're essentially working with something very similar to function arguments. When we work with functions, we pass in arguments to customize how the function body behaves. With generics, we are going to define classes and functions, and we're going to customize the different types inside of those class and function definitions by passing in a type as though it kind of were somewhat like an argument. Generics are going to allow us to define the type of a property inside of a class, the argument to a function, and the return type of a function at some future point in time. And we're going to use generics very heavily whenever we are writing reusable code. Now this diagram right here is not super helpful, so let's take a look at a quick code sample to give you a better idea of what is going on with generics. Back inside of my code editor, I'm going to make a new file. This file we're not going to save, I'm just going to do some quick little examples inside of here. So first I want to write out a little bit of code that has nothing to do with generics at all. So I'm going to say right here, nothing to do with generics. I just want to write out a quick code sample to help you understand how we really think about function arguments. Okay, so I'm going to write out a simple function called add1. So add1 is going to take some argument that's going to be a number, and then it's going to eventually return a number as well. So inside the function body, I'm going to say a plus, as you might guess, 1, because the function is called add1. Now let's imagine that we have some other requirement inside of our application where sometimes we need to add 1 to a number, and sometimes we need to add like 2 or 3. Well, one really silly way to accomplish this would be to just duplicate the add1 function. We'll call it, say, add2. And maybe add2 is going to take a and add 2 to it. And maybe we need to add 3 as well. So we do something like add3, and this one's just going to add 3. So notice the pattern here. Every time that we want to change some value inside the function, we are duplicating the function and then just changing some hard-coded value inside the function. Now, of course, this is really silly to do. A much better way to approach building out this collection of functions right here would be to just build one function called simply add. And then rather than having a hard-coded value right there, we could accept that as a second argument. So I'll call it like b, that's going to be a number, and then we can do return a plus b. So now rather than having 3 different function definitions, I have one, and I can call add with like 10 and 1, add with 10 and 2, and add with 10 and 3. With each of these function calls, we can imagine that this argument of 1 right here is being received as the argument of b, and so inside the function body, we can kind of imagine that we are replacing b right there with 1. Right? That's not quite what is going on, but we can imagine that is what is happening. So the entire point here is that when we make use of function arguments, we customize how the function behaves when we actually make use of it. So with that in mind, let's now take a look at generics. And I really want you to understand that all this generic stuff is very, very similar to how arguments work inside functions. Okay, so I'm going to delete all that stuff, and I'm going to write out a new class definition inside of here. So I'm going to call a class or create a class called old number. This thing is going to have a data property that is a number. So then I would create an instance of this by saying something like old number is a new old number. And then if I wanted to assign that data property, I could say old number.data is 123. Now let's imagine, very similar to the collection of functions we just put together, maybe we have some other requirement inside of our application where we also have to have a class that has a reference to a string as well. So one really silly way to accomplish that would be to create a second class called holdString. And maybe this has a data property as well that's going to be a string. So then we can say holdString, it's going to be a new holdString. Now we can say holdString.data is some string like so. So just like that function example, this is silly right here. We would never define like duplicate class definitions and just sub out one single property inside there or one like series of characters. So rather than defining these separate classes, we could instead use a generic. The generic is going to customize the definition of this class in the exact same way that that b argument in the functions we were just looking at customized the body of the function. Okay, so I'm going to delete this code one more time. And I'm going to write out a single class that's going to basically do the same thing that these two right here are doing. But I can use a generic to customize the types inside of it on the fly. So I'm going to make a new class called holdAnything. It's still going to have a data property, but then for its type, I'm going to add in a little additional syntax right after the class name right there. I'm going to put in a set of angle brackets, and then I'm going to receive a type as an argument to the class. So the type that I'm going to put in here, I'm going to give a argument name to. I'm going to give it a name of something like type of data. So again, we can imagine this right here as being an argument just in the same way we had that B argument into those add functions. So now inside of my class definition, I can freely refer to type of data in any location where I need to refer to a type. So for data, I'm going to say, oh yeah, this data is going to be of type of data. So now I can create an instance of hold anything. And when I create the instance, I'm going to pass in essentially an argument for type of data right here. Remember, when we call a function, we have to pass in a value for each argument. In the exact same way, when we define a generic, we have to pass in a type for this generic value right here. And we are treating this as though it were an argument to the entire class body. So underneath the class definition, I'll say const hold number. So as you might guess, I want to create a copy of hold anything that's going to specifically be made to hold a number. So I'll say new hold anything, and then I'm going to put down another set of angle brackets right here, and I'm going to provide a type that's going to be used inside of the class body. So I'm going to say right here, number, and then I'll put down my usual set of parentheses right after that. So number right here is doing the same kind of thing that a function argument is doing. We can imagine that the class definition is receiving number, and then inside of the class definition, everywhere where we have type of data, it gets replaced with number instead. So this generic right here is saying, okay, give me a copy of hold anything that is customized to work with numbers. So once again, can't say it enough, when we work with generics, just view it as though it were exactly like a function argument. When we call a function, we pass in an argument to customize how the function works. When we use a generic, we are saying when we create an instance of the class, we're going to pass in an argument of sorts to customize how the class works. So now underneath this, I can say hold number.data is going to be some number. And if I hover over .data, you'll notice that there's an annotation on here that says data is of type number. So when we see type of data right here, every time we see type of data, it's going to be replaced with number. So now we can reuse this class definition as many times as we want with different types. So I can say hold string is going to be a new hold string. And for the generic type right there, I'm going to say, yep, this thing's going to be a string. Oops, sorry, I called it hold string. I meant hold anything. So now we can imagine that type string is going to replace type of data everywhere inside the class body. So like that's going to be a string and that's going to be a string as well. And now I can say hold string dot data will be a string like so. And of course, I need to actually change that back, type of data. And when I do so, I can now hover over data, and I get a type annotation saying, oh yeah, in this case, data is a string. If I can actually hover over it, there we go. There's the type annotation. Okay, so can't say it enough, treat generics like function arguments. At the end of the day, very similar in nature. So hopefully you can kind of understand how we might be able to use this strategy right here in solving our match data issue. So rather than having a hard-coded match data and match data right here, we could instead turn our abstract class CSV file reader into a generic class. So we can add on a generic annotation right here of something like type of data, and then we can use type of data wherever we have match data. So right there, and right there as well. So now whenever we create an instance of CSV file reader or otherwise make use of it, because remember, this is an abstract class, we can't actually create an instance of it. Whenever we make use of CSV file reader, we're going to add in those little angle brackets, and we're going to specify the type to use inside the class in place of type of data. All right, now one thing I am going to change here, whenever you start working with generics, by convention, rather than giving this thing a really long name, usually we will refer to it simply as T instead. So you'll see like T right there, and T right there. Now this is just convention. There's nothing special about calling type of data T. And as a matter of fact, there's nothing special about calling it type of data anyways. We can call this anything we want, about like anything we want, literally. Just like a argument name. It can be any type, or excuse me, any name that we want it to be. But again, by convention, usually we refer to it as T like so. So when you start looking at some TypeScript source code written by other engineers, you're going to sometimes see a lot of references to something called T. So whenever you see T, that is a reference to a generic type. Okay, so now that we've got a better idea of what's going on with generics, I'm going to save this file right here. We're going to come back in the next video, do a quick recap on generics, and then make sure that it's really clear that you understand why this is going to solve the issue inside of our CSV file reader. In the last video, we spoke about how we can make use of generics to customize the different types that are flowing around a class. Now, we spoke about changing the type of the data property right here, but just to be clear, we can use the generic for anything inside the class body that we want. So for example, we could have a function inside of here called like add, and we can say that maybe add takes an argument of type T, and it returns an argument of type T as well. So now in the case of hold number, we could call hold number dot add and pass in some number. Oops, one thing I forgot, we need to make sure we actually return that argument a like so. So now by putting together an instance of hold anything that is customized to work with numbers, we can once again imagine that everything that says T inside the class, capital T, like right there, oh, can't do my multi-select, there we go, is going to instead say number. Okay, so we're going to use this feature to solve all of our issues with CSV file reader. So CSV file reader is now going to be a generic class. So whenever we make use of this class in any way, shape, or form, we're going to have to pass in the type to customize CSV file reader. So that means we're going to say, okay, when we use CSV file reader, we're going to pass in match data. And we can imagine that match data will then go around and replace all the capital T's inside of here like so. Okay, so now that we understand what's going to solve this issue, I'm now going to take our type data definition, because we don't need this inside of this file anymore. I'm going to cut it out, and I'm going to put it over inside of match reader. And then likewise, back inside of CSV file reader, we now have an unused import for match result, so I'm going to delete that out of there as well. Then back inside of match reader, we now have an error around CSV file reader, and it says, okay, you've got a generic type right here, and if you want to use this type, you have to provide a type argument to it. So at CSV file reader, I'm going to put in that generic notation, and inside those angle brackets, I'll say the type that I want to be applied to T inside of CSV file reader, which is going to be match data. And that's pretty much it. Okay, so now we've got a very reusable CSV file reader. There's no reference to anything about football.csv or the different types inside of it inside of here. Instead, it is a generic class, so we can customize the different types that are flowing around it on the fly. In this case, we are customizing the CSV file reader over inside of match reader. So we're saying, give us a copy of match reader that's going to extend CSV file reader that has been customized to work with match data. So now everything inside of our application should work as long as we fix up a little bit of code inside of index.ts. So I'm going to flip back over there. We still have a reference to CSV file reader here. Remember, we are no longer going to create references or instances of CSV file reader. Instead, this is going to be a match reader. So I'm going to update the import statement and update the file as well. And now we can create an instance of match reader like so. And that's pretty much it. So now we can save everything, flip back over to our terminal, and we should see Man United won 18 games. Awesome. You'll notice I still have that big console log here. I'm going to fix that up really quickly. Where is that coming from? That's somewhere around here. Let me just try restarting this really quickly. Yeah, there we go. Okay, Man United won 18 games. Much better. All right, so this definitely works out pretty well. And this finishes up version 1 of our refactor. So this is version 1, where we are making use of CSV file reader in a abstract class plus generic to achieve some amount of code reuse. So let's take a quick pause right here. When we come back to the next video, we're going to start to refactor CSV file reader a second time and take a look at a very different way of getting some amount of code reuse without using an abstract class. So quick pause, and I'll see you in just a minute. In the last video, we finished up our first refactor of CSV file reader. So we achieved code reuse here by making use of an abstract class and generics at the same time. This was definitely a pretty tricky implementation. I think it definitely works, but yeah, it's definitely kind of confusing to understand what's going on. So in this video, we're going to start to refactor our CSV file reader once more. we're going to use a very different approach that I think in some regards is easier to understand and in other regards is a little bit more challenging. And this is why I wanted to show you both approaches. Okay, so to get started, we're first going to do a little bit of work on our code base. I want to keep a copy of this file, CSV file reader, around, along with the match reader that we created as well, because we're going to do a direct compare and contrast between both these approaches at the end of this application. So to keep a reference to both these different files, I'm going to create a new project, or a new directory inside of SRC called inheritance, because that's essentially what we used here to solve this whole big issue. I'm then going to drag and drop CSV file reader.ts into that directory. And if it asks me if I want to update any references, no, I don't want it to do any automatic updates. And then I'm going to drag and drop match reader inside there as well. I'm going to move again, and I'm going to say no, do not update any imports. All right, so now I've got a backup of both those files inside of inheritance. And now I'm going to go back to the backup of CSV file reader that we created a while ago. And I'm going to change the extension on there from .back to .ts. Okay, so now we're essentially back where we were several videos ago before we started this refactor. So we've now essentially got a clean slate. So now that we've restored our project, let's take a look at a diagram to help you understand what the second refactor we're going to do is going to look like. Okay, here we go. So with this approach, we're going to lean heavily upon interfaces. We're still going to create a class called matchReader, but it's going to have a very different relationship to the CSV file reader. So before, CSV file reader was a parent class, and we extended matchReader using it. This time around, matchReader is going to essentially stand on its own. It's going to be its own separate little class. MatchReader is going to have a property that we will call reader, and it's going to be of type dataReader. DataReader is going to be the interface you see up here. So remember, when we make an interface, we are creating a new type, and other objects inside of our application can opt in to satisfying this interface by implementing the same properties with the same exact types. So dataReader is going to say, okay, to be a data reader, you must have a read function that returns nothing, and a data property that is a two-dimensional array of strings. You'll notice that those two properties right there look very similar to the properties that we have on CSV file reader. So CSV file reader is going to be essentially a data reader that can work with that data reader interface. So the idea here is that we might have eventually several different readers inside of our application. Like this one is called CSV file reader, but maybe we've got another one at some future point in time called like network reader, or how about API reader? So maybe this class, CSV file reader, gets information out of a CSV file, but API reader can get information from some remote API. Both of them satisfy the data reader interface, so we can assign either of them to this reader property. So then on matchReader, when we eventually want to load up data about all of our different matches, we can call some function on there called like load or something. The load function is going to look at the reader, and it's going to call the read method on it. After completing the read method, we can then access all the data that has been loaded on that data property, and we'll do the actual data conversion process, where remember we turn the date into an actual date, and those numbers or those strings into numbers and so on. We can do all that inside of this load method. Okay, so that's the general idea. So let's take a quick pause. We're going to come back in the next video and start implementing this solution. In the last video, we spoke about the second approach we're going to take to refactoring our project. This approach is going to lean heavily upon interfaces rather than inheritance. All right, so let's get to it. I'm going to flip back over to my editor, and I'm going to make a new file inside of my SRC directory called matchreader.ts. So this file is going to hold our interface and the class matchReader as well. So I'll first define my interface of data reader. I'm going to say that this thing needs to have a read method that doesn't return anything, and a data property that's going to be a 2D array of strings as well. Then after that, we'll define our class matchReader. We know that this needs to have some reader property who's going to have a type of data reader. So we could add in that property right here of like reader data reader. But chances are that we want to have the reader be customized inside this class. In other words, whenever we create an instance of the match reader, we probably want to pass in the actual reader that we want to use, because in some cases, we might want to use a CSV file reader, and in some cases, we might want to use the API reader instead. So we should make the reader that we're going to be using an argument to the constructor. So rather than initializing the property right here in line or declaring it right there in line, I'll instead use that shortcut where we define our constructor. And then in the constructor, we'll say public reader is going to be of type data reader, like so. Remember, that is shortened syntax. That's going to automatically define this as a property on the class, like so. All right, now one last thing. I did not add in an export statement for the class, so I'm going to do that right now as well. Okay, so this looks like a pretty good place to get started. So let's take a quick pause right here. When we come back in the next video, we're going to start doing a big refactor of our CSV file reader. This refactor is going to be a little bit nasty, so I just want to put it in its own standalone video. So I'll see you in just a minute. In this video, we're going to start refactoring our CSV file reader. There's a lot of stuff inside of here that needs to be fixed up, so we're going to do it step by step, line by line. So first off, everything having to do with a match needs to get moved over to the match reader. Remember, the entire goal of all this refactoring is to make sure that CSV file reader is 100% standalone and reusable. So it should have no reference whatsoever to anything having to do with a match. So that means that we're going to move the entire conversion process of all of our data over to the match reader. That means that our CSV file reader no longer needs the date string to date function. So I'm going to cut that import and move it over to the match reader at the top. Next up, match result, once again, should have no references to match inside this file. So I'm going to cut that out and move it over to match reader. We then have our tuple definition. Well, same thing, should be no references to match data inside this file. So I'm going to cut that and move it over to match reader as well. All right, now going down the list here, our CSV file reader is no longer going to be dealing with a data property that is match data. Remember, CSV file reader, we want this to satisfy the data reader interface. So data needs to be a two-dimensional array of strings. So I'm going to update data right there to string two-dimensional, like so. Next up, if we scroll down a little bit, we've still got that mapping statement right here where we do the actual data conversion process. So again, no data conversion inside of here whatsoever. So I'm going to cut out that .map. We should still have the original .map right there. And I'm going to paste the rest of all that stuff, everything I just cut, directly inside my class body. We're going to reformat that in just a second. So for right now, I'm just going to paste it and comment it out. So now if I go back over to CSV file reader, I should see no errors inside of here whatsoever. In fact, I should see 100% generic code, nothing related to matches. All we have is some CSV file reading logic that we can absolutely use on future projects as well. Okay, so this looks pretty good. So now the last thing we have to do is make sure that match reader has a load method. Anytime we call load, we need to attempt to read data from our data reader, and then we're going to do that conversion process on data. So quick pause, and we'll take care of that in the next video. All right, my friends, we've got our CSV file reader all put together and in a very reusable state. So now the last thing we have to do is implement our load method on match reader. The load method is going to load up our information through the CSV file reader and then do the actual conversion process. So let's get to it. Back inside of my code editor, I'm going to find my matchreader.ts file. Right underneath the constructor, I'm going to define a new function called load. This is not going to take any arguments, and it's not going to return any values either. So inside of here, we're going to take a look at the reader that we were provided. Remember, the entire idea here is that reader can be maybe the CSV file reader or an API reader or some other source of information. So whatever reader we were given, we're going to call this.reader.read. So that's essentially the entire loading process. That's going to tell the CSV file reader to go get the CSV file, parse all the information inside of it, and produce that two-dimensional array of strings. So after we call read, we can then take a look at this.reader.data, which again is the two-dimensional array of strings, and we'll do the actual transformation process, where we take those 2D strings and we turn them into all the appropriate values, like the date and the numbers and the match result and so on. So to do that step, we can uncomment the .map statement we saved, cut it, and paste it onto this .reader.data. Okay, so just like before, we're looking at the two-dimensional array of strings. We're going to map over it and produce a new array where every element inside the new array is going to be a match data tuple. Now, one last thing here. Remember, a mapping function doesn't mutate the underlying array. Instead, it gives us a new array back. So this entire statement is going to give us a new array that we have to save somewhere. So let's save it as a property of the class. To do so, we need to first define a new property on the class itself. So I'm going to say that this is going to have some property like matches. It's going to be an array of match data tuples, and I'm going to initialize it to be an empty array. So then after we do that mapping operation, I'll assign all that transformed data to this .matches like so. And that's pretty much it. Okay, so that's all we have to do here. So now the last thing we have to do is update our index.ts file to make use of match reader and CSV file reader. So let's take a quick pause and then update the index.ts file in the next video. The last thing we have to do is make sure that our index.ts file attempts to create an instance of match reader. Now, the important thing to keep in mind here is that when we create an instance of match reader, we have to pass in some value that satisfies the data reader interface. And so right now, we only have one class that satisfies that interface. It is the CSV file reader. So that means that inside of our index.ts file, we are creating an instance of match reader and CSV file reader as well. Okay, so with that in mind, let's flip back over to our index.ts file, and we're going to do a couple updates inside of here. So first off, I'm going to delete these two lines right here because if we try to update these in place, things are going to be just a little bit confusing. I'm then going to import the CSV file reader at the top, like so. And now we can actually make use of this stuff. So the first thing we need to do, once again, create an object that satisfies the data reader interface. So that's step one. And then step two is going to be to create an instance of match reader and pass in something satisfying the data reader interface. So again, it's a two-step process now. Before we were just creating one class, now we are creating two separate classes. And the idea here is that by creating two separate classes, we can kind of customize where the match reader is getting its information from on the fly. All right, so let's get to it. First, create the object that satisfies the data reader interface. That is CSV file reader. So we'll say const CSV file reader. Notice the lowercase characters there is going to be a new CSV file reader. And we once again still have to pass in the name of the CSV file we want to open, which is football.csv. So now that we've created our source of information, we can now create the actual match reader. So we'll say const match reader is new match reader, and we're going to pass in to the constructor the source of information to use, which is the CSV file reader. So I'll pass in CSV file reader. Okay, so we've now got the match reader, but remember, just creating it is not enough. Once we create it, we then have to call the load method. The load method is what's going to actually tell the reader to get all of its data, and then transform all that data and assign it to the matches property. So now we're going to call match reader dot load, like so. And then finally, now anywhere beneath this, we can now reference match reader dot matches. And that's going to be the information that we want to actually iterate over for our analysis. And so that means down here inside of our for loop, we are no longer iterating over reader.data. Instead, we are iterating over matchreader.matches. So I'll update that to matchreader.matches like so. Okay, so let's save this file. I'm going to flip back over to my terminal, and we should still see Man United won 18 games. Awesome. Now, if you don't see anything here, just hit Control-C and restart that process. Remember, you can restart it with an npm start. And you should see Man United won 18 games like so. Oh, there we go. All right, perfect. Okay, so let's take a quick pause right here, and we're going to do a big retrospection on the two refactors we've now gone through. So quick pause, and I'll see you in just a minute. All right, my friends, we've now completed two very big refactors on our project, and we've seen two very different styles of getting some amount of code reuse out of our CSV file reader. So now in this video and the next couple, I want to do a big retrospective and try to decide whether or not one approach was better than the other. So let's get to it. Now this discussion really boils down to a discussion around inheritance versus composition. So that's what we are really describing here. We just went through a very solid example of getting some amount of code reuse by using inheritance. And then the second refactor we did really focused on using composition to get some amount of code reuse. So let's first make sure that we understand what both these terms are referring to, and then we'll discuss which one might be better than the other in this particular application we are working on. So first off, inheritance. Inheritance is the case where we had the abstract class called CSV file reader, and then we had a child class based upon it called match reader. So this was an inheritance scenario because we wanted to have a parent class that had some really core functionality around a CSV file reader. We then extended that class and created a child class out of it, and we kind of customized some of the behavior. We customized the behavior by implementing map row. So again, this is what we would refer to as inheritance. Anytime we are inheriting from a parent class, we refer to that as an inheritance. So then the second big refactor we did was an example of composition. Composition was characterized by the fact that we had a class called match reader, and the match reader had a reference to some other object. We said that this reader property right here had to be any object that met the data reader interface. Then anytime we called the load method, rather than relying upon the match reader to 100% source our data, we instead kind of delegated, so to speak, the actual action of loading up some data to this outside data reader. And we said that the benefit to this approach was that we could very easily swap in different styles of readers to customize how the match reader behaved. And when we start to think about inheritance versus composition, a better way of thinking about it, or kind of a mnemonic you can use to decide which style you are using at any given time, is either a is a relationship or a has a relationship. So whenever we make use of inheritance, we are saying that we have two classes that are kind of bound together by a is a relationship. So in other words, when we look at, say, match reader, we say match reader is a CSV file reader because match reader has all the different methods and properties that normally belong to a CSV file reader as well. So match reader is a CSV file reader. But in the case of composition, we have an has a relationship. So in this case, match reader had a reference to some outside object, like our CSV file reader. And anytime that we wanted to load up some data, we delegated that actual loading up operation to that outside object. So again, we imagine these two types of relationships as being an is a relationship or a has a relationship. Now this doesn't quite help you really understand what's going on behind the scenes, so let's take a quick pause right here, and I want to expand on this idea, of inheritance versus composition. In the last video, we introduced the idea of inheritance versus composition, and I had said that inheritance is characterized by is a, whereas composition is a has a relationship. Now this isn't super useful right here, so let's walk through another quick example to really help you understand what's going on. All right, so I want to imagine for a second that we're going to work on a very different application. We're not going to actually write any code. This is just a quick experiment. And I want to imagine that inside of our application, we have to somehow model a window, like a window in a house. So we might say that, okay, let's try taking some inheritance-based approach here, and we're going to try to create a class of window. And maybe it's going to have some properties like the one you see right here. So we might have like an open flag to indicate whether or not the window is open, and then some method to change the open state. And then, of course, a window has some dimensions, like a height and a width, and maybe at some point in time, we would want to calculate the area of the window as well. Now let's imagine for a second that in addition to a class called window, maybe we also want to have a class called wall. Well, when you look at wall over here, I think a wall would probably have a color that's a string, and then it would probably also have a height, width, and area. So notice that both window and wall share some common characteristics. They've both got a height, they've both got the width, and they've both got an area as well. And so chances are that we're going to have some amount of code duplication between these two classes. So to avoid any amount of code duplication, we might decide to create some common parent class for both of them. So maybe some relationship like this. So we might create a class called rectangle, because a rectangle kind of represents the shape of both a wall and a window. Rectangle would have a height, width, and area of method, and then we would create wall and window and make sure that they extend rectangle. So wall and window would then borrow all of these different methods and properties. So in this relationship, we would say that wall is a rectangle, and that window is a rectangle as well. We're using classic inheritance here. We are borrowing properties and methods from some parent class. Now this might seem like it works out pretty well, but there's a really easy way to throw a wrench in this whole system. So let's imagine for a second that we have a window that is not rectangle. Maybe we have some other kind of window inside of our house that is actually circular in nature. And this is entirely common. I don't know if you've ever seen one before, but houses all the time have circular windows. So we would not be able to use our class window that we already created right here to represent a circular window. Instead, we would have to create an entire another class hierarchy in parallel. So we would continue to have our class rectangle with height, width, and area, and that would be used as a parent class to wall, and then maybe we would rename our window to rectangle window to indicate that this is a rectangular flavor of a window. And then to represent a circular window, we might create another parent class called circle, and this might have a radius and an area that returns a number. So now we would create a circle window using the parent class of circle, and circle window would have to have its own separate definition of whether or not the window is open, and also some method to toggle whether or not it is open as well. So now right away we can see very easily that we've got some code duplication going on. These are both windows, and they differ in a very, very slight fashion. Just the shape, that's it. But we would end up having to duplicate this open property, and we'd also have to duplicate the toggle open method as well between those two classes. Now, chances are the implementation of toggle open and open would be very simple, but hey, the point here is that we would have some amount of code duplication. So one way that we could solve this whole problem is to abandon inheritance entirely and try using out a composition-based approach instead. So if we used a composition approach, here's what we would do. We would create a class to represent a wall and a class to represent a window. Both wall and window would have a reference to some other object that matched some interface, and maybe we'd call that interface shape. So then rather than having class and window inherit from some other class, we would say dimensions are going to reference some particular shape. So I can say that, okay, class wall, I want to have a wall with a rectangle or rectangular dimensions. So when I initialize or create an instance of class wall, I could give it a reference to class rectangle. I could just as easily give class wall a reference to class circle instead. And then on class wall, I would probably add on an area method. And anytime that we called area, rather than trying to compute the area ourselves inside of class wall, we could instead kind of delegate that area calculation to whatever our dimensions object was. And so that means that eventually we would be calling area on the rectangle or area on the circle instead. And the same thing with window as well. We would have a reference to some object that matches a shape interface. And so this would be a reference to either class circle or an instance of a circle to be precise, or an instance of rectangle. And then anytime we call area on class window, we would delegate that calculation to our dimensions property. And so we would still be up to the shape to reflect the area of either the window or the wall. So the benefit to this approach right here is that by using composition and giving an object a reference to another object, we can much more easily create some more complicated looking objects without having to completely duplicate a class hierarchy. So this is way more closer scenario to our second refactor that we put together. That's exactly this relationship right here. We had class match reader. It had a reference to some other class or some other object. On match reader, we had a reader property, and we said it was going to be of type data reader. That was an interface. So because we're using an interface here, we can freely swap what object we assign to reader. As we said several times, right now we're making use of CSV file reader, but we could easily create some other type of class, like maybe API reader, that got information from some totally other different location inside of our application. And so we can easily swap out these different objects to distinctly change the behavior of match reader without having to actually really change any code. So that's why we generally like to make use of composition. It's sometimes a lot easier to make an object with a lot more reusable code. And it keeps us from having to duplicate code all over the place if we just want to make like one very small change to some particular attribute. Now we're going to see instances of composition throughout the rest of this course, and we're going to continue to look at some more instances of inheritance as well, so we can continue to get a little bit more of a distinction between both approaches. So let's take a quick pause right here. There's one last topic around composition and inheritance that I want to talk about in the next video. In this video, I want to talk about composition versus inheritance just a little bit more. This discussion is going to be kind of unrelated to the application that we're working on. Nonetheless, this feels like a really great opportunity for me to clear up some confusion between composition and inheritance in the JavaScript community. So feel free to skip this lecture if you want, but I highly recommend that you stick around because it's going to help you understand that there really is a huge misconception around composition. All right, so let's get started. First things first, if you've ever read a blog post around object composition versus inheritance, you might have seen this exact quote right here. It says, favor object composition over class inheritance. So this is from a book that was written many years ago. The book was not specifically about JavaScript. The book was actually written for, I believe, C++. Nonetheless, people have kind of latched onto this phrase in the JavaScript community and used it as like a selling post for saying, hey, we should favor object composition. Well, here's the issue. It turns out that's probably the most misunderstood statement ever in the JavaScript community. Now, the statement itself is correct. The statement itself, the authors go on and give a very strong argument for saying that we should favor object composition. The issue is that if you go on to Google right now and you search for JavaScript composition versus inheritance and you look at all these different blog posts, all these different videos, if you read them, you're going to find that their definition of composition is 100% incorrect. So maybe composition versus inheritance is like some debatable topic. The issue is that everyone's understanding of the word composition in the JavaScript world is just plain wrong. So my goal here in this video is to help you understand what the authors of the book were talking about when they use that statement, and what the people who are writing all these blog posts are talking about when they discuss composition. Now, my goal here is not to like shame anyone in the JavaScript community. That's not what I'm trying to do. What I'm trying to do is make it really clear that, hey, we really messed it up, our definition of composition, and it's really important for us to correct that understanding and correct that definition, because otherwise we got tons and tons of engineers who are going to be writing really, really weird code because they think that these authors, like the authors of this book that we're going to take a look at, were saying one thing when in fact they were saying a very different other thing. Okay, so let's get to it. Let's first take a look at the book. We're going to understand their definition of composition. We're then going to look at a blog post, understand the blog post definition of composition, and compare and contrast the two. And I think you'll find that they are very, very, very different definitions of composition. All right, so inside of design patterns, again, this book was written many years ago. It was not written specifically for JavaScript. I'm going to go down to, I think it's page 40 or so. Here we go. All right, page 40 says here very clearly, favor object composition over class inheritance. And again, this is the phrase that gets repeated over and over and over again. So let's take a look at this book's definition of what composition is. We're going to scroll down just a little bit. You can read this stuff right here, but it doesn't really tell us a whole bunch beyond just what that sentence says. So the next section is about delegation, and they're saying the delegation pattern is one way of making composition a very strong pattern. So delegation is kind of like a tool or a method of implementing composition. They then go on to describe exactly how delegation works. So let's take a look at their example of how delegation works right here. They're saying, notice how they're using the exact same example I just gave you. They're saying instead of making window a subclass of rectangle, just because the window happens to be rectangular, the window class might instead reuse the rectangle by, and here's the important part, here's the super important part, keeping a reference to the rectangle instance variable and delegating rectangle specific behavior to it. So in other words, instead of a window being a rectangular, it should have a, that's the has a relationship we were just talking about. So a window should have a reference to a rectangle. And that's the example we just looked at 2 seconds ago with that diagram right here. Oh, no, not that one. This one right here. So we said that a window should have a reference to a rectangle, or generally to some kind of like shape object. And we can easily swap that object out, and that's how we get code reuse. So when the book talks about composition, they're saying very specifically, all right, we're going to favor delegation as a pattern to implement composition. With this pattern, we have some class that has a reference to another object. And anytime some request comes in to like get the area of the window, our window class is going to delegate that calculation off to this dimensions object or to that outside object. So that is what the book is saying when it talks about composition. So now we understand that. Let's take a look at one of these random blog posts online, and we'll try to understand what all these different blog posts are saying around composition. And again, just about every single one of these blog posts, not correct. Okay, so now I pulled up one of these blog posts. I deleted as much identifying information out of it as I can, because again, I'm not trying to shame anyone here or anything like that. I just want to clarify this misunderstanding. So let's take a look at what their claim of composition is. So in this example, they're creating a function down here called fighter. Then inside of fighter, whenever they call it, they're going to create an object that they called state. And state has some different properties that describe a fighter. Now, a fighter needs to have some number of methods attached to it to actually make this object useful. So right here, they're saying object assign. Object assign is going to take all the different properties out of this object and essentially copy paste them over to this object. Now, does that phrase copy paste ring a bell? Does that not sound, I don't know, kind of a lot like something we were talking about earlier in the course called inheritance? Yeah, it kind of does. Just keep that in mind for a second. So obviously, we need to understand what canFight does right here. canFight is defined right here. So they pass in that state object that has all their kind of instance variables tied to it. And then inside of canFight, all they're doing is returning an object that has some different methods attached to it. And the idea is that these methods right here are going to attempt to work on those instance properties like name or stamina or health and so on. So when these authors of these blog posts are talking about composition, they're using the literal definition of composition in the dictionary, in like an English dictionary. They're saying, oh yeah, we're using composition because we have the ability to kind of build up an object by composing it from multiple different sources of methods. So yeah, like the word composition in the absolute sense of the English language, sure, I can buy that. But the issue is that when they are quoting the book that says favor composition over class inheritance, this is not, it's two different types of composition. In the book, composition means one object has a reference to another object, or possibly multiple other objects. All these blog posts are saying, let's build up the definition of an object by using different sets of methods. Now, to make sure that you really understand what these blog posts are saying, let's write out a really quick example to try to emulate how we would build up the definition of a window. We're going to write out this example using JavaScript because, to be honest, it's just about impossible to implement using TypeScript. All right, so I'm going to pull open a quick JavaScript editor here inside my browser. If you want to write out this code as well, you can go to stevengreider.github.io/playgrounds. All right, so this is a code editor. On the left-hand side, we can write out some stuff, and the result of it will just be printed immediately on the right-hand side. So just a really quick place to write out an example. So I'm going to follow the same pattern we just saw in that blog post. I'm going to create a function here called rectangular. And the goal of this function is to take in some state object that, remember, has some like instance variables tied to it. And then we're going to return an object that has some methods that I want to eventually use in some definition of something that is rectangular. So if something is rectangular, chances are we want it to have like an area method, right? Yeah, that makes sense. So I'll give it an area method. And then inside of here, I will return state.height times state.width. So I'm very clearly kind of making the implication here that this state object that's coming in must have a height and a width property. After that, I'll define maybe like some openable function. And the goal of this is to give a door, presumably, the ability to toggle itself open or close. So I'm going to return an object that has methods to implement that behavior. So I'll give it a method like toggle open. And inside of here, I'll say state.open is the opposite of state.open. So that's definitely some like toggling behavior right there. So now here's the important part. To combine these behaviors together, or to kind of like compose them, so to speak, into an object, we would write a single function down here called like build rectangle window that's going to be called with some state object. Now this example is slightly different than the blog post we just looked at. In the example we just looked at, they defined that state object directly inside of this function that was intended to actually build an instance of an object. We're going to say we're going to pass in those instance properties as an argument, because that's way more flexible than what that example had that we were just looking at. All right, so then inside of here, we'll say return object.assign state rectangular with state and openable with state. Now the code here is just a little bit confusing. Remember, it's not super critical for you to understand exactly what's happening here. We're basically saying take the state object, throw it into openable. When we call openable, it's going to return an object that has some methods on it. Then take the state object and throw it into rectangular. That is also, oops, I've switched openable and rectangular, but you get the idea. So return an object that has some methods on it. So essentially, this right here is going to turn into an object that has some methods. This is going to turn into an object that has some methods. And then we're going to take all those different methods and copy paste them down to the state object. So now to actually create a rectangular window, we would say something like rectangle window is build rectangle window, and we'll pass in our state object. So this would presumably have like a height property, a width, and some like open state that will start off as false. So now to actually use this object, like this is the actual instance of the object we care about, we could do things like say rectangle window dot open to see whether or not the window is open or not. You'll notice we get false as the output. So then we could call rectangle window dot toggle open. That should toggle the open status. Then we can print out rectangle window again, and you'll see that now it's open. So again, the entire idea behind this approach is that we have these kind of separate definitions of methods, and we're going to combine them together to actually build a usable object. So when all these blog posts are using the term composition, again, yeah, sure, I can like buy that this is some form of composition in the strictest sense of the literal English definition of composition, because we are composing the behaviors of an object by combining them together. But the big point here is that this is just plain not the same definition of composition as you find in this book. And this quote right here is what everyone is quoting. These authors, who are some very, very, very smart people, said, you should use this pattern right here over class inheritance. And then we've got all these authors who are writing blog posts who are saying, oh, when they said composition, they're saying this thing. And what they're saying, just not what the authors of this book are talking about. So again, yeah, sure, I can buy that it's called composition, and that's really where the confusion comes from, but it's not the same composition. And so the authors are not saying, the authors of this book right here are not saying to do this. This is not what we want to do. This is just plain not a good pattern. And I can show you why this is not a good pattern very, very easily. Let's say for some reason openable right here also has an area method. Right? Okay, well, what does that mean? That means that when we have some object that combines the methods from rectangular and openable, which area method are we going to actually get? The area method that we end up getting here just comes down to the order in which we list them out in the object.assign statement. So this entire pattern right here is incredibly fragile if you ever happen to have any methods with the same name. If you ever do, that's pretty much it. You can't combine those different sets of methods together because you're going to very quickly get some super unexpected behavior. This entire pattern that you're seeing here, some of these blog post authors are calling it like concatenative inheritance or something like that, or concatenative composition, I think, as kind of like an alternate definition. What it's really called is multiple inheritance. That's what we are really doing here. So we're building up the definition of some like rectangle window thing by combining all the different methods from something that is openable and rectangular. So you can kind of imagine that, yep, we're going to copy paste, literally copy paste in this case, all those methods and all these methods down to rectangle window. And remember, once again, earlier on in this course, Copy-paste methods? Gee, that sounds an awful like inheritance. That's exactly what the blog post authors are advocating. It is multiple inheritance that they are showing here. They are inheriting methods from multiple different sources. Okay, I think that's enough. I think you get the idea of where I'm coming from here. Again, so much of these community-produced articles around composition are just really often left field on this topic. So hopefully this gives you a better idea of what these book authors were talking about when they were discussing object composition. So in this course, we're going to stick to like the book definition of object composition as much as we possibly can. We're still going to look at some examples of class inheritance just so you get an even balance of both approaches. Okay, so like I said, that's enough. Let's take a quick pause right here and we'll continue in the next video. In the last couple of videos, we've gotten really far off course. So in this video, we're going to start working on our big list of issues again. The conclusion of this application is going to come very quickly. So we're going to finish up this entire app rather fast now that we've covered some of these really big topics. So the last three issues on here are essentially all very closely related. The first issue is that we had a variable named after a specific team. So that was inside of our index.ts file. We had a variable called Man United Wins. This variable really only made sense when we were looking at the number of times that some team called Man United won a game. And if we ever wanted to find out the number of times some other team won a game, well, chances are this variable name of Man United Wins would not make a lot of sense. After that, we've got a fixed analysis type. So right here, we've got only one type of analysis that we can really do. And if we ever want to have some different kind of analysis, well, we would have to delete or otherwise comment out this analysis, which remember, usually is a sign that we cannot easily swap in or swap out different code. And then finally, we don't really have the ability to output our report in different formats. Right now, our format, or our output, is a very simple console log. And so I don't have the ability to print out maybe like a PDF report or an HTML report or anything like that. So we're going to essentially fix all these three issues in one go by making use of object composition. Remember, we just spoke about object composition in great detail. The idea is that we're going to give one object references to other objects. And then the main object is going to essentially delegate certain behaviors out to those third-party objects. So let me show you a diagram of how we're going to try to structure this next big refactor of our application. All right, so here's the idea. Now, we're not going to create every one of these things you see right here. Some of these are just for examples, so you would understand why this approach is going to make a lot of sense. We're going to create a new class called Summary. I think the class name is probably not the best, and we could probably figure out a better class name here. If you can think of a better name, certainly feel free to do so on your own project. The goal of class Summary is essentially to coordinate the analysis phase and the reporting phase. So class Summary is going to have a reference to some object that satisfies the analyzer interface. The idea here is that the analyzer interface is going to require some other class to implement a method called run. Run is going to receive all that big list of matches that we've parsed, and then it's going to have to return some string that represents the output of that analysis. So an analyzer, or something that implements this interface, is essentially responsible for running some analysis on our data. So for example, we might create a class called Average Goals Analysis that implements that interface. And as you might guess, this class would have a run method that would try to figure out the average number of goals scored for maybe some particular team or for every single match. We might also have a class called like Wins Analysis, and maybe that's going to determine the total number of goals that some particular team scored, or like the total number of wins that some team earned. So by creating this class analyzer and using composition, we're going to be able to easily swap out these different types of analysis. Now, in a very similar thought, we're going to also have a property called output target. And this is going to have to be an object that satisfies the output target interface. The output target interface is essentially trying to specify some reporting output. So once we get some output or some report of sorts from our analyzer or some actual data, we need to actually put that information out somewhere. So something that satisfies the output target only has to have a single method called print, and it's going to take in some report that's a string. So the output target might be satisfied by like a class called console report. And so console report, as you might guess, might just take a report as a string and console log it out to our terminal, and that's it. We might also create a class called HTML report as a substitute that would take in a report string and then save it out as some HTML file or something like that. So the entire idea here is that summary is kind of like the coordinating object. It's going to have a reference to some object that's going to be the analyzer and implement some very specific analysis. And it's also going to have a reference to some output target that's going to take a report and try to report it to some very specific channel. To actually start up that entire process of building the report and then sending it somewhere, we'll probably put a method on class summary called build and print report or something like that. So when we call build and print report, it's not up to the summary to actually build and print the report. It's going to delegate those behaviors to these objects that it has reference to. So this is another example, like perfect example of how delegation and composition really is going to work. All right, so now we understand what's going to go on. We're going to write a whole bunch of code rather quickly because I think that we've got a pretty good idea of what's going on here. So let's take a quick pause right here, and we're going to start banging out some code in the next video. All right, in this video, we're going to start doing a big refactor once again. So we're going to add class summary, add some interfaces, add some other classes. You get the idea. One thing I want you to notice right away, however, is that just about every one of these different things has a reference to that match data tuple type. Right now, our match data tuple is defined inside of our match reader file. So here's where we define that tuple. We're definitely going to have to refer to this tuple type in other locations inside of our project. And so I think just to make life a little bit easier, we might want to move this type definition into its own separate file so we can very easily import it. And all these other files won't have a dependency upon match reader. So let's try that out right now. So I'm going to create a new file inside of my src directory called matchdata.ts. And then inside of my match reader, I'm going to cut the match data type and paste it inside of match data. I'm going to make sure I export this type, and then you'll notice this thing also has a reference to match result. So of course we need to make sure we import match result into here as well. We'll import match result from match result. And then I'll save this file. Okay, that looks good. So now everywhere where we need to make use of match data, we can just import this type from this file. We need to make sure we do that right away because we just removed that definition from match reader. So I'm going to go back over to match reader. At the top, I will import match data from match data. Cool. Okay, so now we can start with the actual different classes we need to build. So we're going to first start off with class summary. So I'm going to make a new file inside of src again called summary.ts. Inside of here, we're going to define two interfaces and one class. Let's start with the interfaces first. So the first interface we need to define is analyzer. So I will do an export interface analyzer. One thing I put in that export keyword, we don't actually have to export an interface. Remember, other objects inside of Typescript can implicitly satisfy an interface. However, in this case, remember, we can optionally use an interface definition to help us actually satisfy that interface when we write out a class. And that's what we're going to do this time around. To do that, we need to export the interface. I know that probably sounds really confusing. I said it all very quickly. So let's just throw on export for right now. Later on, in just a little bit, when we start putting together these classes on the right-hand side, I'll show you exactly why we are exporting that interface. It'll be more clear at that point in time. Okay, so our analyzer is going to have just one method. It needs to have a run method that's going to take in a list of matches. That's going to be an array of match data tuples. And then it has to return a string. That's the actual data from running our analysis. So I'm going to say this thing has to have run. It's going to take an argument that we'll call matches. It's going to be an array of match data tuples, and it has to return a string. Now right away, we get an error around match data. So that's why we just extracted that to its own separate file. So let's import that in here right away. Cool. Okay, now we can define our second interface of output target. So I'll do export interface output target. This thing needs to have a print method that takes in an argument called report as a string and doesn't return anything. So print report, that's going to be a string and doesn't return anything. And then finally, we can set up our actual class definition for the summary. Now again, summary is a class name here I really don't like that much. I had previously called this thing analysis, like so. But then we had a class called analysis and analyzer inside, and that was just really not clear, I felt like. So calling it summary just kind of helps give a little bit differentiation against the analyzer property. Again, if you want to call this something else, absolutely feel free to do so. So I'm going to create a class called summary. I'm going to make sure I export it. Now here's the key, the total key to composition. When we define an instance of class summary, we are going to pass in an instance to use, an instance of an object to use as the analyzer, and an instance to use as the output target as well. So in other words, when we create an instance of class summary, we have to pass in to the constructor one of these different analysis objects over here, and one of these different reporting objects over here. And those are going to be used to be assigned to the analyzer property and the output target property. This is the key to object composition. We're going to configure summary when we actually create an instance of it. So with that in mind, I'm going to define the constructor function, and we're going to use that shortcut for defining an instance variable. So I'll say public, and then we're going to pass in our analyzer, and it needs to be of type analyzer. And then the second argument will be public, and we're going to pass in our output target. And it needs to be of type output target, like so. Now I'm going to save this. It's not going to wrap the line, but I'll do it manually for you here just so you can see this entire constructor definition. So now as an example of how we would actually use something like this, we would say new summary, and then we would have to pass in something that meets the analyzer interface. So maybe a new average, or how about a new wins analysis? So new wins analysis. And as the second argument, something that satisfies the output target interface. So a new, like console report. That's what this is going to eventually look like. Now, as you might imagine, this kind of approach right here of using composition and passing in these instances when we create the parent instance starts to get really verbose. And there actually are some third-party tools to make this entire process a little bit easier. We may or may not take a look at them inside this course because they are ridiculously complicated. So we'll see how far we get. Okay, so now that we understand the general goal here, I'm going to save this file, we'll take a quick break, and we'll continue in the next video. In this video, we're going to start working on some of the different analyzers that we're going to have inside of our project. Remember, something that meets the analyzer interface is going to be a class that actually runs the very real analysis for us. So it's going to find maybe the average number of goals per game, or the number of wins per team, or whatever it is. So let's start working on our first analyzer. We're going to implement our wins analysis class. The wins analysis class is essentially going to be the same exact thing we are currently doing inside of our index.ts file. We're just going to give it the name of a team. So for example, maybe Man United, and it's going to tell us the number of times that that particular team won a match. That's it. So pretty much the same thing as what we have right here, but we're going to wrap it up inside of a class. So to get started, inside my src directory, I'm going to make a new folder, and I'm going to call it Analyzers. And I'm going to eventually put all of my different analyzers inside this directory. So the first one we're going to create, wins analysis. So inside that new directory, I'll create wins analysis.ts. Then inside of here, I'm going to export class wins analysis. Now remember, this class right here needs to satisfy the analyzer interface. So the way that we can satisfy that interface is by obviously implementing that run method. But remember, if we want to, we can have Typescript give us just a little bit of help with the implementation. If we want to get just a little bit of help, we can import that interface and then use the implements keyword when we define our class. And that means that Typescript is going to check our class to make sure specifically that it successfully implements that interface. We've done this once before. Remember, it is 100% optional. You don't have to do it, but it's nice to have Typescript kind of check your code for you if you want to. So just to be clear, that is also why we exported our analyzer interface and the output target interface. So we can import these into these other files and use them while we are writing our code to make sure that we are implementing the interfaces correctly. So back inside of wins analysis, at the very top, I'm going to import analyzer from up1 directory, because remember right now we are inside analyzers, and I want to take a look at that summary file. I want to get the analyzer interface out of there. So now here's the optional step. We can say implements analyzer, like so. And that right there is what's going to tell Typescript, hey, we're trying to get this class to implement this interface. Give us some help. Check our class for us. So right now, if we hover over it, it says, hey, you're not implementing this interface correctly. You have to have that run method. Again, can't say enough, 100% optional, totally up to you if you want to use this on your own projects. Okay, so inside of here, we want our wins analysis class to take in the name of a team and find the number of times that that team won a match. So we need to provide the team probably as a constructor argument. So I'm going to define the constructor. I'll use that shortened syntax and say public. We're going to get the team, and that's going to be a string. Now, of course, if you want to, you can call this like team name. That might make it a little bit more clear. I'll just call it team though. So now that we've got the name of the team that we want to find the number of wins for, we can define our run method. Remember, the run method is what is required by our interface. So if we go back over to our interface definition, it's going to tell us that the run method has to take in an array of match data tuples and then return a string. Remember that the argument name inside the interface, that's only there to give you and I as developers some context. When we implement the run method, we don't have to call that first argument matches if we don't want to. We're going to use matches just because, hey, it makes a lot of sense, but we don't have to exactly match that name. Okay, so back inside of wins analysis, we're going to get matches. That's going to be the array of match data tuples. And then we eventually need to return a string that's going to be the actual result of this analysis. Now, right away, we get an error around match data because we have not imported that type into this file. So I'll do that at the top. We need to go up one directory again, so notice the .. and then we're looking for match data, which is where our tuple is defined. Okay, so now inside of here, we can do the actual analysis. Now, just to save a little bit of time, I'm going to go back over to my index.ts file, and I'm just going to cut and paste the existing analysis we had done over here. We're going to need to change a couple things, but this will definitely work to get us started. Okay, so I'm going to cut that stuff. I'm going to go back over to wins analysis and paste it inside of run. I'm going to reformat just a little bit. And now we're going to do a little bit of renaming inside of here. So first off, yeah, calling this Man United Wins, probably not a good idea. I'm just going to call it wins instead. So I'm going to update there, there, and there. So I should now see wins 3 times, 1, 2, and 3. Next up, inside of our for loop, you'll notice that we are still trying to pull data off of our match reader. That doesn't exist inside this file. Now all of our different matches are going to be provided as an argument. So we can update the for of loop to iterate over simply matches like so. And then finally, we've got an error down here around the match result. Remember, that is our enum, the enum that has either home win, away win, or draw. So to make that error go away, we can just import the enum definition at the top. Up one directory again, match result. And those errors go away. All right, so now the very last thing we have to do is actually produce and return a string using the analysis that we've conducted inside this method. So after the for loop, I'll do something like return, and then a string describing the result of this analysis. So I'll say like team, this.team, won, and then I'll print out the number of wins this team won. Like so. Okay, so that looks good. That is our first analyzer. So this is a standalone class that's going to take all of our match data, run some analysis on it, and then return a result. So in theory, we could create as many of these classes as we want to, and each one could implement a different type of analysis. Remember, back in this diagram over here, I gave the example, maybe we would create a separate class that tries to find the number of average goals per game, or something like that. Now, one thing I just want to mention really quickly here as well, we are not restricted to just the run method here. If our class needs to have some other methods inside of it to actually complete an analysis, that's totally fine. We can absolutely add on helper methods. Remember, an interface, like the one we are implementing right here, doesn't restrict the number of methods we can have inside of a class. It only requires that we have a certain number with some given name and signature. That's all it does. Okay, so this looks good. So let's take a quick pause right here. When we come back in the next video, we'll start putting together the console report, and we'll be able to start testing out our project again. So quick pause, and I'll see you in just a minute. In this video, we're going to start implementing one of our report classes. So remember, these things need to satisfy the output target interface. Their general goal is to take the report that we generated during our analysis and then just send it to that target. So like in this case, maybe the console. So we would do a console log. If we had a HTML report class, well, it would probably generate some HTML file or something like that. So let's get started on generating first our console report class. All right, so back inside my editor, I'm going to make another new directory inside of src called report targets. And then inside this directory, I'll make a new file called consolereport.ts. So I'm going to use that same importing the interface thing that we used just a moment ago. Remember, we just imported an interface into Win's analysis just to help us implement that interface inside the file. Again, not required, it just makes life a little bit easier. So in this case, the interface we care about is defined inside of summary.ts. We want to import the output target interface so that we make sure that we implement it correctly. So inside of console report, I'm going to import output target from up1 directory, and then we're going to get our summary file. So then inside of here, we can do an export class console report implements that interface. And so again, we are told right away, okay, hey, TypeScript understands you're trying to implement this interface. Well, right now you're doing a pretty bad job of it. You need to make sure you implement the property print. So let's do that right now. We're going to implement print. If we go back over to our interface definition, we will see that it's supposed to take in a string and return nothing. So this is going to take in a string and return nothing. So like we said in the case of console report, well, this is pretty much just going to take the report and console log it. So we can just do console log report, and that's it. That's the entire implementation. So I think you can agree with me that in this case, while this is a really simple and straightforward class, nonetheless, hey, it's a valid use. We will do the HTML report as well, so you can see one that's just slightly more complicated, but to be honest, at the end of the day, it's going to look very similar to what you see right here. Okay, so we've now got something to actually do the analysis. We've got something to actually run the report. Now, the last thing we have to do is make sure that we actually put in some implementation inside of our class summary. So that needs to have a build and report method that's going to take in all that match data. It needs to take that match data and pump it into the analyzer. Remember, the analyzer has the run method that needs that match data to run correctly. The analyzer is then going to return a string to use as the report. So then build and print method will take that string and toss it off to our report, or our output target, I should say. So let's now implement build and print report inside of class summary. So back inside of summary, underneath the constructor, I will define build and print report. This thing needs to take in our list of matches, which is going to be an array of match data tuples, and it's not going to return anything. So then inside of here, we're going to take a look at the analyzer we were provided, which is available as this.analyzer. And on that thing, we're going to call run and pass in the list of matches that we were given to this method. So now run is going to give us back a string, and that's going to be the actual report that we now want to somehow give to the user. So I'm going to save that report, or maybe I could call it report or output. I don't know, either one. I'll call it output here. And then with that output, we can now hand that off to our output target and have it be reported to some given target, like the console or HTML file or whatever else. So to access that, we would do this.output target. So this.output target, we'll call the print method, and we're going to pass in that output from the analysis. And that's pretty much it. So again, the big thing to keep in mind here, this is like a perfect example of real composition. Our class summary doesn't really have a lot of behavior to it, like really just basically nothing. Instead, it has references to other objects. Whenever we send a command or call a method on summary, summary is not really responsible for doing anything. Instead, it is going to attempt to use these different objects that it has references to actually do the heavy lifting. So summary is really like a coordinator of sorts. And the great thing about this approach is that we can freely swap out the analyzer or the output target and get different outputs of information or generate different kinds of reports. Okay, so this looks pretty great. This is a really strong structure here, a really strong pattern. So now the last thing we need to do is actually get this thing running inside of our index.ts file. So let's take a quick pause right here, and we'll fix everything up inside of index.ts in the next video. Now that our summary is complete, the last thing we have to do is create one inside of our index.ts file and actually try to run our build and print report method. Okay, so back inside of index.ts, I'm going to do a little bit of cleanup inside of here first, so I don't need the console log at the bottom anymore. Next up, I don't really need match result inside of here anymore, so I'm going to delete that as well. So now inside of index.ts, I only have the code that's required to actually read that CSV file, and then take all the information out of the CSV file, parse it, and make it available on this match reader variable. Remember, the actual parse data is available on matchreader.data, or excuse me, matchreader.matches, my mistake. So now we're going to import the three classes that we just created, our console report, the summary, and our wins analysis as well. We're going to use all those together. So at the top, I'm going to import console report from our report targets directory. I'm going to import wins analysis from our analyzers directory. And then finally, I will import summary from the summary file. So now we're going to create an instance of summary wins analysis in console report. Console report and wins analysis will be fed into summary. So down here, I'll say const summary is a new summary, and the first argument to this is going to be the instance of our analyzer, which is wins analysis. Oh, let's get that new keyword on there. And then the second argument to the new summary constructor is going to be our console report. So new console report. Now, one thing I missed on here, when we create an instance of wins analysis, remember we had said that you have to pass in the name of the team that we want to find the number of wins for. So I need to make sure I pass in an actual string here for the team we want to find the wins for. Let's do Man United again, Manchester United again, like so. So to now actually build the report and print it out somehow, all we have to do is call the coordination method of sorts on summary. So that's going to be summary dot build and print report. And we have to pass into that thing all the different matches that we want to use for the analysis. And so that data is going to come from our match reader. So we could say match reader dot matches. That is our array of match data tuples. And that's pretty much it. So I'm now going to save this file. I'm going to flip back over to my terminal, and I should still see Team Man United won 18 games. Awesome. Okay, so this is an example of composition brought all the way through. I've repeated several times what composition is all about, so I'm going to save your ears from saying it one more time, but I think that you can agree with me that it would be kind of nice to see maybe something just slightly more complex than our console report. So let's take a quick pause right here. When we come back in the next video, we're going to try putting together a different type of reporting target. We're going to try to create just a very, very simple HTML file that's going to take in some result of an analysis and then print it out inside that HTML file. So quick pause, and I'll see you in just a minute. In this video, we're going to put together another reporting class that's going to take the result of an analysis and just throw it into an HTML file. So let's get right to it. Inside my report targets directory, I'm going to make a new file called html report.ts. Then inside of here, I'm going to import the output target interface that we had defined inside of summary. Remember, importing the interface and using it inside of an implements clause, not required, totally optional. So inside of HTML reports, I will import output target from up1 directory, summary. Then I will export class HTML report, and I'm going to say this thing needs to implement the output target interface. And once again, we get some information here telling us, hey, this thing better have that print method. So inside of here, we can define our print method. It's going to be given the report as a string, and it's not going to return anything. So then inside this method, we're going to generate a tiny little HTML snippet and then write it to an HTML file. So to generate the HTML snippet, I'll say const HTML is going to be a string template. So notice the backticks here, because we want to use a multi-line string. If we use single quotes, well, we're going to get a syntax error very quickly. So please make sure you're using those backticks. Then inside of here, I'll put down just a little bit of very simple HTML. So I'll place a div. How about an H1 that says analysis output, and then a div, and inside there, I'll just dump the report that we were given. Okay, so this is going to generate some HTML, and now we want to stick it into an HTML file. So to do so, we're going to use that FS class that we spoke about, or the FS module, from the Node standard library again. Remember, we use the FS module inside of our CSV file reader to read a file off our hard drive. So now we're just going to do the exact opposite. We're going to attempt to write a file. So back inside of HTML report, at the top, I'm going to import FS from FS. And then right after we create our HTML string, I'll call FS write file sync. The first argument to this, well, I can tell you, or you can command click on this, or even just hover over it and get some documentation. So if I hover over it, the tooltip right here says that the first argument is going to be a path. So essentially the name of the file that I want to generate, or actually write to my hard drive. And then the second argument is something called data. And I bet you can imagine, yeah, data is probably supposed to be like the actual information we want to write into that file. So once again, we don't have to look at the documentation. We can use these type definition files to understand what we are doing here. So for the first argument, I'll say report.html. It would be nice to be able to pass in the name of a file as a constructor argument, but I'll leave that as an exercise up to you. And then the second argument is going to be the actual data we want to write into the file. So in this case, this snippet of HTML. So I'll say HTML like so. Okay, so that's pretty much it for our HTML report. So now the last thing we have to do is flip back over to index.ts. At the top, I'm going to import the HTML report that we just created from our report targets directory /HTML report. And then finally, down when we create our summary, rather than passing in an instance of console report, we will instead pass in an instance of HTML report instead. Okay, so now the instant I save this file, remember our code is going to be reran at the terminal, and so we should see a HTML file generated inside of our root project directory. So I'm going to save this file. Very shortly after that, I'll see report.html generated because, well, we just generated the report. And so now we can open up that file inside of our browser. If you are on Mac OS, you can open up that file very easily by opening up your terminal and running open, then the name of the file, which is report.html. So open report.html. If you're on Windows, you can just open up your folder explorer, find your project directory, and open up that HTML file. And so now I can see analysis output as an H1, and then a div that says Team Man United won 18 games. Now, obviously, this is a super, super boring report, but again, the point here is that by making use of an interface and object composition, we can very dramatically change the behavior of our application without having to make dramatic changes in the actual code. Okay, so I think that we've spoken quite a bit about composition now, so I'm not going to repeat any of this stuff that you've heard me say many times. So let's take a quick pause right here. This application is pretty much all wrapped up, so let's do a quick wrap up and talk about some of the high points of this app in the next video. In the last video, I said that our application was all wrapped up, but I can't help myself. Just one last little thing. I swear you will like it. It's going to condense some of the code inside of our index.ts file just a little bit. So like I mentioned several times, having to create a new instance of summary right here, and then pass in new wins analysis and new HTML report, well, that's just a little bit verbose. Chances are, whenever we create a summary, we might always want to have the same analysis, or we might want to always print out an HTML report. So having to always pass in those instances every time we create a summary, well, there's just got to be a better way. So in this video, I want to very quickly show you how we can kind of add in a shortcut for this statement right here. We can also use this technique to get a shortcut for the previous use of composition that we had up here as well. Remember, this is doing the same thing up here using composition. We first create an instance of CSV file reader and then pass that into match reader. So I want to show you the shortcut that we can use in both these locations. So to create a shortcut, I'm going to open up my summary.ts file again. Inside of summary, we currently have a method inside of here. Remember, methods can only be called once we have created an instance out of this class. So in other words, to call build and print report, we have to say const summary is new summary, pass some stuff in, and then we can call summary build and print report on the instance we created. There's another type of method that we can add to a class called a static method. Static methods can be called off the class itself. So in other words, if I add a static method at the top of this thing, which I can do by writing out static and then the name of the method, so how about just like print hello? And inside of here, I do a console log of print or just hi. I can now call this method because it is marked as static without creating an instance of summary. So down at the bottom of the file, I can say summary.print hello like so. No issue whatsoever. However, if I try to call print hello, or try to call build and print report off the class itself, I'll very quickly get an error message. Because the class does not have a method called build and print report. It's only on an instance of summary. So how can we use these static methods to get a little shortcut here? Well, essentially, we can create some static methods that give us back pre-configured instances of summary. So we might decide to make a static class method on here called summary, or how about like, what would be a good name here? How about wins analysis with HTML report? Really long, but I just want to give you kind of like an idea of what this method would do. So maybe if we call this method, it would give us back a copy of summary or an instance of summary that already has wins analysis and an HTML report loaded up into it. So let's try that out. To actually put this together, we need to make sure we import wins analysis and HTML report at the top. So I'm going to do that right now. I'm going to import wins analysis from the analyzers directory. And then I'll also import HTML report from the report targets directory, like so. So now down inside of our static method right here, we can say return a new summary, and we're going to preload this thing up with instances of wins analysis and HTML report. So the first argument will be new wins analysis. Second argument will be new HTML report. And then remember, wins analysis needs to know what the team name is. So we would probably need to pass through the team name from this method itself. So we'd probably want to receive the team name as an argument to this class method. So I'll say team is string like so, then we can just pass through team. And then finally, I'm going to make sure I annotate the return type of this method as well. It's going to return an instance of summary like so. Okay, so now anytime that we want to create an instance of summary that already has these things loaded into it, we can just call this class method. So let's try that out. I'm going to save this file, flip back over to index.ts, and now rather than writing out this really long statement right here, we can just call summary.winsAnalysis with HTML report and pass in our team name right there of Man United. Notice that when we use a class method, we don't have to use the new keyword. We do eventually use the new keyword inside the class method. So inside of here is where we actually use new. So the one thing that's kind of bad about this approach is that it is not immediately evident that we are returning an instance of summary, as it is when we were previously using the new keyword here. So yeah, kind of a downside there, but in general, kind of a little bit less code. Now, of course, I used a very long method name for this, but I only used the long method name just to make sure that it was really clear what we were doing with this method. So now I can save this file, flip back over to my terminal, and oops, looks like, let me just restart here. I'm going to hit a Control-C, npm start again. And you know what? I think I must have missed a step in here. So let's take a quick pause. I'm going to hunt down that issue, and then we'll find out what is going wrong. Oops, in the last video I said that there was something going wrong. There's nothing going wrong. We don't get any output at our terminal when we are using the HTML report. My mistake. Okay, so just one more quick example of these static methods. Let's try doing the same thing for the match reader as well. So right now, our match reader only ever gets used with the CSV file reader. So let's add a static method to match reader and just say, hey, this thing is always going to be created with a CSV file reader. So to make that happen, I'm going to open up my match reader file. Here it is right here. At the top, I'm going to import CSV file reader from the CSV file reader file. And then I can add on a static method. So I'll say static. And how about for this name here? Again, we could do something really descriptive about from CSV. I think that makes sense. Now we'll make sure that we pass in the name of the CSV as an argument. So I'll pass in file name as string, and this thing's going to return an instance of match reader. So then inside of here, we can return a new match reader that gets pre-configured with a CSV file reader. Oh, let's get that new keyword, and then make sure that we pass in the file name to the CSV file reader. There we go. Okay, so we can save this, and then back inside of index.ts, rather than writing out all the stuff you see right here, I'm going to delete those comments. I'm going to delete the declaration for CSV file reader. I'm not going to call new match reader anymore. Instead, I'm going to try to call that static method that we just put on the class. So I'm going to say match reader dot from CSV, and then I'll pass in the name of the CSV file. So football.csv. Okay, so now we can save this again. And this time I learned my lesson, no output at the terminal. Yep, that's right. We get the report HTML file here. So if we really want to test to make sure that's still being generated correctly, I could delete that file and then just make like an arbitrary change to this thing, save it, and I should see the file regenerated again. Perfect. So now the real benefit to this approach, look at how many import statements we no longer need inside of here. So we can now delete the import for HTML report. We can delete all those other imports as well, and we're left with just match reader and summary. All right, so that looks pretty good. In fact, if we really want to condense this a little bit more or make it a little bit nicer on the eye, I might move the summary declaration next to the other declaration and then put those two commands next to each other. Wow, that's a big improvement. Okay, so that's the last thing I want to show you, just those static class methods. Again, we can use those to return a pre-configured instance of the class. We don't have to use static class methods for returning an instance of the class. We can use these for anything, but in general, using them to kind of generate a pre-configured instance of match reader, that's definitely a good place to get started with them. Okay, so let's take a quick pause right here. I swear that's the last thing, so we'll do a quick review of everything we accomplished here in the next video. All right, my friends, I know we spent quite a bit of time on this project, but I just want to do a quick recap and discuss some of the really important topics we covered. So first off, inside of matchresult.ts, we created an enum. Remember, enums describe a set of values that are all closely related. Enums don't really carry a lot of intrinsic value inside them. Their real goal is just to communicate to other engineers that, hey, here's a set of values that are all closely related. We also saw a very practical example of using tuples. So we created a tuple to describe a single row of a CSV file. Remember, when we made use of the tuple, there was kind of two separate steps going on. On the one hand, we had to actually convert the strings that were coming in from that CSV file to the appropriate type. Once all those values were in the appropriate type, we could then describe the entire row using the tuple. So just creating the tuple didn't actually convert any values for us. We had to do the conversion manually. Making the tuple just allows us to describe the ordered types inside of the array-looking thing. I don't want to use the word tuple again. The next big thing we saw was inside of the inheritance directory. So remember, these two files are kind of backups right now. We created the abstract class CSV file reader, and we made this thing a generic class. We only spoke about generics very briefly, so we're still going to do a lot more with them inside this course. We used a generic here because we wanted to configure the types inside this class definition on the fly. Remember, you can think of this generic definition as being like a function for types. So anytime we reference CSV file reader, like anytime, we have to pass in essentially an argument for t. Remember, t, there's nothing special about calling this thing t. Really, you can imagine this thing is instead called like type for data. But convention is to just call it t. So that's how you can imagine it. but all the documentation, all the blog posts you're going to see, they're just going to call it T as a shortcut. We eventually made use of this abstract class inside of our match reader inside the inheritance directory. So inside of here, we extended CSV file reader, and notice that's how we provided eventually a type to our generic. And we eventually decided that, hey, this approach was good, but we want to try out something different than just inheritance. And so that's when we started looking at composition. And so we had several different examples of composition going on inside this project. First off, we had our match reader. Here it is right here. So the match reader, we said we're going to provide a data reader to this thing when we create it. So the data reader was going to be the source of information. So data reader could have been coming from a CSV file or an outside API or even like direct user input, whatever we want it to be. So match reader's job was to load up some data. It delegated the loading of actual data, and match reader only worried about providing an implementation for converting that incoming data into the match data tuple that we just discussed. The other big example of composition that we saw was inside of summary.ts. And we just did a ton of stuff around this file, so I don't think I really need to repeat anything inside of here because you probably just heard me talk about this several times over. Okay, so this was a really awesome project to highlight some benefits of composition. And even though it was a really long project, I hope you enjoyed getting a very practical comparison between inheritance and composition. So let's take a quick pause right here. We still have got a lot of work to do, so I'll see you in just a minute. In the last application we worked on, we discovered the topic of generics. Before we move on to our next application, I want to very quickly cover generics again and go into a little bit greater detail just so you understand how they work. So to get started, I'm going to change out of my project directory, and I'm going to go back into that features directory that we were working on way earlier on inside this course. I'll then start up my code editor inside there, and we're going to write out one or two quick examples. All right, so to get started, inside of my root project directory, I'm going to create a new file called generics.ts. Then inside of here, I want to first begin by writing out a class that kind of represents a simple array of numbers. So I want this to have a simple property of maybe something like collection to reference an array of numbers, and then maybe one method that we'll just call get that will allow us to get some specific element out of that array of numbers. So I'm going to make a class array of numbers. I'm going to define the constructor method and say that this thing will be called with some collection of data, and that has to be an array of numbers like so. And then we'll say that this thing has a single method called get. And whenever we call get, we have to pass in the index as a number, and that should receive, or retrieve, I should say, some element out of our collection of data. So this is going to return a number. Then inside of here, we can say return this.collection at index. Well, pretty much simple enough, right? Nothing too crazy here. So let's now try to create an identical class, but rather than representing an array of numbers, we'll instead have it represent an array of strings. So right underneath, I'll say class array of strings. This thing will also have a constructor with some modifier of public on the first argument that we'll call collection. This is going to be an array of strings. And we'll do an identical get method on here as well, but instead of returning a number, we're going to return a string because now we're dealing with an array of strings. So I'll say get index at number. That's going to return a string. And to actually return that, we'll do this, or excuse me, return this.collection at index, like so. So this is an example very similar to the one that we just saw in the application we went through. We have two classes that are just about identical in nature. The only big difference between the two of them is the presence of the type of collection. So in the first one, we've got a number. Anytime that we get an element out of that array, we will be returning a number. And then likewise down here, we have an array of strings. Anytime we get an element out there, we're going to have a string. So ideally, we would be able to condense both these classes down to one. And one way to do that would be to make use of generics. So let's define a new class down at the bottom of the file now, and we're going to make it a generic class. So I'm going to say class array of anything. Right after the name of the class, I'll put down those brackets and then T inside them. Remember, we think of T as being just like an argument. There's no special meaning to the word T or the letter T here. We could call it type in this class. You can call it anything you want, but again, by convention, we usually refer to it simply as T, like so. So now we can look at either of our implementations up here, and we're essentially going to say everywhere that we see number, or specifically number that's referring to the array that we are working with, we're going to replace it with t. Now, do remember when we see index right here, that's going to stay indexed as a number because the index coming into the get method, well, it always needs to be a number. So we'll say constructor public collection. This is going to be an array of t type, like so. We can then define our get method. So that's still going to be called with a number, but now we're going to return an element of type t from it. So then we can return this dot collection at index like so. All right, so that's our generic class right there. Once again, just picture this as being like an argument. Anytime we now reference this class in any way, shape, or form, so if we want to create an instance of it or refer to it as a type or whatever it might be, all we have to do is write out array of anything, and then those brackets, and then the type that we want to have specified for t inside that body of the class. So for example, if we now wanted to have an array of strings, we could say new array of anything, and then put in just the word string right there, and then pass in our starting collection. So that would be an array of strings, A, B, C, and so on. Okay, so this example that we just looked at is basically similar to what we just saw in the application we just worked on. So of course, there are a couple of other elements that I want to show you here. So let's take a quick pause right here. When we come back to the next video, we're going to continue on with generics and learn a couple corner cases around them. So quick pause, and I'll see you in just a minute. In this video, I want to point out one or two corner cases around generics, specifically inside of classes. All right, so down here, we wrote out new array of anything. And when we created that instance of array of anything, we specified a type for t inside of that class definition. So when we put string right here, we can imagine that we went through the class definition and we replaced t with the word string, like so. So that's what we can imagine is going on behind the scenes. Now here's something really interesting. If I delete that specification right there of angle bracket string, you'll notice that it appears that everything still works out just fine. If I assign this instance of array of anything to some variable, I'll call it, say, ARR like so, and then mouse over ARR, you'll notice that it has already filled in for me a type annotation that says array of anything with angle brackets of string, even though you and I did not actually specify that. So how did Typescript figure out the type of array of anything for us? Well, this is another instance of type inference. So here's what's going on behind the scenes. When we create a new instance of array of anything, we pass in an array of strings right there. And Typescript knows that is an array of strings. Remember, Typescript is very intelligent. So we pass in that argument right there, and that shows up as the variable or the argument to the constructor of collection. So Typescript is going to look at the type of collection that we just passed in. And it's going to say, oh, it is an array of strings. So even though you and I did not specify a generic for type t, Typescript is going to assume because we just put in an array of strings, well, then t must be string. So again, that is type inference. We spoke about type inference way long ago when we were discussing type annotations, and it applies to generics as well. So with type inference around generics, it turns out that we've already been making use of generics quite a bit throughout this course, even though you might not quite have realized it just yet. In particular, you might remember the very first application we worked on involved Axios. It turns out that when we made use of Axios, well, Axios is a generic class. So when we made use of Axios, we had some specific return type, but we didn't actually have to annotate it when we made use of Axios back on that very first application. And that is thanks to type inference, or type inference around generics specifically. Now, understanding type inference around generics can be a little bit tricky. You really need to look at a couple different examples of it. So let's take another quick pause right here. We're going to come back in the next video and talk a little bit about how we can use generics with functions in addition to classes. And we'll see another good example of type inference over there as well. So another quick pause, and I'll see you in just a minute.